and the wait is over for repairing this. Okay, now we will go to repair this inverter because finally we received the control drive card and new LCD. Okay, the previous live video of removing all the components, the video link in the description of this video. You can watch the previous live video. The previous live video description was added in this video description. Okay, let's get started. So first I am wearing my gloves. Okay, and now first we need to keep all these components in this box. Okay, for easy holding or keeping. Okay, first we need to keep these components in this box. Okay, this is the zipper. This was the zipper shopper. I keep all the damaged or true components and this. Now we can need to check everything one by one. Okay, I am keeping this zipper shopper again for next. Okay, and for this screws and connectors and thermopad we need another box. Okay, because this is the sensitive. So I get another box for this. And now I am removing the thermopad because this is very sensitive. Okay, I removed this. I was removed this successfully. Okay, this is a little bit dust, but the status as you can see. Okay, this is the perfect for the use. So now I am keeping here. Okay, and this is our big capacitors and screws. We have in this thing a big capacitors and the body screws. Okay, let's check the capacitor shrink tube. Okay, now we are isolating again this. Okay, in this video. So this is our big components. Okay, I am keeping this on the bench. Okay, and this is all the body screws and nuts, so we need to keep in this box. Okay, and now we are going to repair this finally because the bed is over. I'm so excited to repair this. Okay, and this is not my first time to repair. And I get a third box for these sensitive screws and isolators and connectors, as you can see. Okay, we have no any screw or anything in this. Finally I'm getting this. Okay, now we need first of all to check the main power supply. Okay, and now I am rotating the mobile for good direction. as possible. Okay, if I rotate this, okay, and a little bit I am adjusting here, okay, because I was also working on this board on this direction. Okay, so first of all we need to check the power supply. Do not install the card in this condition. Okay, first we need to check all the power supply voltages. Okay, because the, here I am showing you we have already received damage L7805. Okay, and after that we need to check the negative voltage regulator 7912. This is the negative voltage regulator. Okay, so now I am providing the power supply. This is the 48-volt system. Okay, DC input battery voltage 48 to 64 volts. Okay, this side is positive. Okay, first you need for better repairing to decrease your power supply voltage, and after that attach. Okay, and after that slowly increase your power supply voltage. Okay, so now I am providing the 48 volts. Okay, and after that I am keeping my multimeter. Okay, so the direction is vertically. I need to first adjust the board. Okay, here first I am checking, so I am keeping my multimeter here. Okay, for good view, first you need to select the DC voltages on your multimeter, and after that we need a switch like that for this board. Okay, this is just a simple switch. Okay, now we have here a switch panel. Okay, a switch strip. Install the switch. Okay, the power consumption is now 0.00 milliampere. Okay, and now I am turning on the inverter power supply. Okay, now we don't have need for install the card. Okay, because first we need to check the power supply. I was turned on the inverter, and now the consumption is 30 milliamps. Okay, this is the good board. Okay, first of all we need to check, this is the L7805, and the middle pin, this is the middle pin connected with this pin. Okay, this body, and this is the pin number 1. I am keeping the multimeter probe. Okay, so here we need a 12 volts around. Okay, as you can see 12.49 voltage here we are receiving, and after that we need on pin number 3 5 volts. Okay, because the component is L7805. Okay, so here we have no any voltages. Okay, first we need to switch off the inverter and remove the power supply. Okay, oh man, no, don't worry about this because we don't have a control card. Now I am removing the L7805. Okay, as you can see, first I need to keep safe area my multimeter, and now I am zooming in the L7805, Okay, this is the L7805. This component converting the DC voltage from 12.5 volt to 5 volt. Okay, so now you can remove this with the two methods. The one method is hot air gun, and the second method is soldering station or soldering iron. But here, in my experience, I'm applying heat with the soldering iron because here is assembly components and capacitor. The hot air is not good for here. Okay, set your soldering station or soldering iron or on 400 degrees centigrade. Okay, and apply some solders to all pin. Okay, but take care for this female headers. Okay, and now you need to add some more solder. Okay, with the pin number 2 once. Okay, now focus on the soldering iron, what I am doing. Okay, first you need to heat these two pins. Okay, and after that you need to heat a body of the L7805. Okay, look like this. Okay, now I am holding and the tweezer. Okay, and don't apply more than force. Okay, now we remove successfully the L7805, and after that we need, with the help of soldering iron, just remove a solder like that. Okay, clean again your soldering tip. Okay, take care. Okay, and you can use here with your experience a desoldering wick. Now I am using a desoldering wick. Okay, for best cleaning. Give some soldering plugs to the desoldering wick. Okay, and now set your soldering station on 400 or 380 degrees centigrade. Okay, and after that slowly move like this. Okay, and after that here. Okay, and now I need to cut this use soldering wick, and now need to apply more soldering plugs to the desoldering wick. Okay, and now I am removing all the old solder with the help of soldering iron and desoldering wick. Okay, now I am applying here. Sorry, I need to add some solder and clean my tap. Okay, for good contact. Okay, now I need to clean this with the help of cotton swab and some thinner. Okay, take care about the SMD components. Okay, and now I am showing you closely. Just one I clean this. Okay, Okay, I was clean here. Okay, as you can see. Okay, now I need to install L7805 here. Okay, that's okay. So here I have L7805. Okay, positive voltage regulator. I am keeping. Okay, for here now we need to some PPD paste, or some people call this to a liquid solder. Okay, we need to use here a PPD paste. Okay, this is melting on 183 degrees centigrade. Okay, so here I am adding some liquid solder or PPD paste, what you want. Okay, I am keeping here this now, and here I am adding a liquid solder, but this is not the liquid solder. Okay, the best method for applying this solder, apply some heat on the board. Okay, a little bit heat, hot air. Okay, a little bit, and now just focus. Okay, and now I am installing the L7805 here with the help of soldering iron. Okay, first I need to clean my soldering tip. Okay, and now I am keeping the component. Okay, and after that I need to apply the heat. Okay, move slowly your soldering tip here for melting the solder. Okay, it's easy with the hot air gun. Okay, but here are some sensitive components, so I am not using here hot air more than. Okay, so now I need to clean the soldering plugs. Okay, okay, here we have some liquid solder. Okay, so now I am thinking about for this. Okay, to melt this. or remove this extra. So we have a teeth fix. Okay, here we have some liquid extra solder. Okay, we can remove this. Okay, with the help of this, or provide some more heat here to melt this. Okay, or use some thinner and a little brush, soft brush. Okay, like that I'm using here some thinner. Okay, and removing this with the help of soft brush. Okay, this is the soft brush. Okay, finally I clean. As you can see, the liquid solder bars or PPT paste come here. So now we need to remove this with the help of cotton swabs. Okay, here I am cleaning this with, as you can see. Okay, now use another side, don't waste. Okay, this is the basics rules of repairing. Okay, what I am doing. I know about all this board topology. Okay, don't worry. And the previous work live stream in the description of this video. So finally we change our L7805, and now we need to check. Okay, first I check before the replacing. Okay, and now I providing a 48 volts power to this board, because this is the 48 volt. Okay, now I'm setting the board for best view. Okay, here is my board, and I'm keeping my multimeter here, as you can see. Okay, and now I am installing the power switch here, and now I turn on the main board power supply, and now this is the pin number 2, GND are common. Okay, negative. Here we have a 12 volts, 12.5 volts around, and here we need, as you can see, 5.033 voltages. Okay, here one another component, we have a negative voltage regulator. The number or name as, the number is L7, sorry man, I'm looking here, I forgot, 7912. This is the negative voltage regulator. Okay, so you need to keep the multimeter positive probe on the pin number 1 for checking this component. Okay, the pin number 1 is G and D, and here are coming voltages, as you can see. Wait man, 17.26. Okay, after that we need on the pin number 3 output 12 volt negative. Okay, so this is the positive already, and here we need to receive 12 volts. Okay, as you can see, our negative voltage regulator is okay. And after that, for best repairing, you need to check the IGBT voltage drive circuit. Okay, so here I need to keep my multimeter. I can keep, yes, I can keep here. Okay, and here as you can see we have a 4 IGBT for converting the DC voltage to AC, okay, with the help of PWM control drive. Okay, this control drive card providing the PWM to this IGBTs, okay, and with the help of this auto couplers, okay. Auto coupler number is TLP352, okay, and the pin number, this is the auto coupler pin number configuration. This is the pin number 1, as you can see the dot is here. This is the 2, this is 3, 4, 5, 6, 7, 8. So our pin number 8 is positive. This is for operating voltages, okay. Now I am setting my direction, okay, because here are voltages coming and we need to check. Okay, I'm standing for best checking. So the pin number 5 is negative, okay, keep carefully, okay, and the pin number 8 is our positive. Here we need a voltages, as you can see, but here is some conformal coating. As you can see the 21.27 voltages. My multimeter is not set here in the camera, so I am keeping here. Okay, don't worry about the multimeter and board, this is my daily work. Okay, here is our negative and here is our positive. It's mean this auto coupler have a power supply. Now we need to check the second. Use your probes very carefully, okay. So here our second positive, as you can see the voltage is coming, okay. After that we need to check 2 more, okay. This all auto coupler is installed on one direction, okay. As you can see 21 point some voltages, okay, and here we need to check the last one, number 4, 21 point some voltages, okay. It's mean our all auto coupler have a power supply. After that you need to keep the multimeter negative probe on the source pin number 3, okay. This is the source pin, and the positive probe on the gate pin, okay. Here we need a negative 4.7 some voltages, okay. This is the very important voltages for IGBT driving, okay. IGBT, isolated gate bipolar transistor, okay. Now here we have another, this is the source pin number 3 and this is the gate pin number 1. As you can see 4.731 negative, this is okay. And after that this is the third, okay. As you can see 4.7 something, okay. And this is the last, we have 4.6. this is all drive, okay. And I am giving tip you, okay. If after when you receive this condition board and if you here not receive the negative voltage, so you need first to check here power supply, okay. And if the power supply is here coming and you are not receiving here a negative voltage, so you need to check the gate drive resistor on the bottom side, okay. Some model is connected with the 100 ohms and some models with connected 47 ohms. Here are we have 100 ohms, okay. But already we have the negative voltages, so we don't need to worry about this. Okay, and after that our second thing is to check the utility charging section. Okay, this is the utility charging section. First we need to install here a bridge diode. Okay, and this non-polarized capacitor. Okay, we have of this area this non-polarized capacitor. This is the 10 NF, no sorry, 100 NF. First we need to check this. Set your multimeter on the continuity, on the capacitance. Okay, like that. Set your multimeter on the capacitance and don't touch your skin. Okay, or any conductive things. And now we have a true capacitance. Okay, as you can see, 100 NF. Okay, so first we need to install the bridge diode rectifier. Okay, for rectification the main AC voltages, and after that we need to check this drive. This is the utility charging system. Okay, so I am installing here a new bridge rectifier for main AC voltages rectification. Here as you can see the symbol positive. Okay, so this is our positive side and we need to put in this. Okay, and we need to install this with some distance, and here we need to leave some extra pin because when we install the heatsink, after that we can fix. Okay, now we have not a heatsink, so we cannot properly cut the extra pins. Okay, so now keep this in your fingers, and first I was teach you so many times, keep the solder like this. Okay, and now I need to install the tip. I remove the tip. Okay, I am installing with the one hand as you can see. Okay, I install the tip and give some solder to your tip temporary. Okay, attach this just temporary to hold the component. Okay, now my hand is free. Okay, so first I need to check this is very deep. Okay, so now I need to remove not, so I need to keep some distance like that. Okay, after that I need to solder all the pins. Okay, just we need to check and set the same distance of all pins. Okay, I just put this approximately. Okay, but we have a slider hole. Okay, we can a little bit adjustment in this bridge diode. So now I am proper soldering the bridge rectifier. Okay, Okay, I solder this. Now we need to cut and we need to leave some extra pin because we need to install the heatsink. Okay, I cut the extra pin. Now I need to install this component. This was already I checked. Okay, so we need to remove the extra solder from the pins. Okay, and now we need to install on his place. Okay, here as you can see in the previous working live stream video, link in the description. Now keep your finger, okay, like that, and again hold your solder like this, okay, and give some solder to your soldering tip and provide this one pin as you can. Okay, and after that now your hands is free and solder this properly. Okay, after that solder this properly. Now we need to solder again and to push. Okay, after that we need to check the control drive of AC charging. Okay, now I am providing the AC charging voltages. Okay, and first I need to check on another device my video what is going on in the camera because I am looking to the board and now I am searching for my live stream on another device. I found my video. Just wait to the internet is very slow here also. Okay, the audio and video is both okay. No any comment. Here I am just setting my tab for best video. Okay, just wait for some second. Yeah. Okay, did not do that. Okay. Okay, now I am providing the AC power supply. Here we have an input line and input neutral. Okay, check this also in series voltages with the halogen bulb, 100-watt halogen bulb. Okay, or 200-watt halogen bulb. Okay, don't provide the direct supply. Okay, direct mean no any series bulb. Okay, now I am providing like that. Cut your wire. Okay, cut here and one side install here and one side this called the series. Okay, with the bulb. Now I am providing. Okay, I attach the power, the AC power. Okay, so now I am keeping the board on another side to teach you. Okay, I am keeping with multimeter. Okay, so I am setting the board. It's okay, and set your multimeter on DC voltages. If you have a manual meter, so you need to set your multimeter on 400 or 600 DC voltages. Okay, like this manuals meters. Okay, if you set this you can damage your multimeter. If you can set this you can damage, so you need to set here. Okay, and this is the auto because this is the fluke. So first we need to check here are DC voltages. Okay, now I am checking as you can see Okay, reverse. Don't worry. Here we are receiving a 290 voltages. Okay, because this is the multiplication, because here installed the bridge diode rectifier. Like that, I am telling some formula, showing you some formula. Okay, here are coming 212 volt AC and Y. Here are we receiving the 290. Note this, man. Here we have a 212 volts. Why here we have receiving the 290? So I am getting to calculator. Where is the calculator? Here is. Oh man, I receive a call. Wait, just forward. I have a call on my mobile phone. Hello? वालेकुम सलाम. जी. हाँ जी सर, खिदमत हूँ. मुस्तान मोबाइल वाला लेकर मोबाइल वाला. Siapa nunggu peso? Jadi dah siapa nunggu peso? Ragal le. But guys, I have a customer. First, I need to handle this. Okay. Don't leave the live if you need. Just wait. Okay. हाँ जी. हम मुस्तान दा नंबर मिलाओ क्या होता. हेलो. वालेकुम सलाम. हेलो. जी जी. शाहिद खबर को जी शाहिद. रोडिंगा अस्ता सुसो यार. सनूम पे निकलो. चार आवड़वा. नंबर किसका हो गया? नंबर दिखाओ. हम इससे हाँ. और 10 नंबर हो गई. नंबर हुआ है मातफल. नंबर हुआ है. सही है. ड्राइवर का मां. सही है. हाँ पासवर्ड में थोड़ा था. बैटरी लो रसीद चार्ज भाई कई चार्ज अवल شنو خاب يا بنور مثلا انا قلت بك موي بس سيتنج صح. دا ولا شيء دا بیٹری دا دایما. ما درنه دا تاسو سره یې مثلا موټر دې کومه په دې باندې موږ سره ودرو. امر اولای دا زما د رو مخ به کې دی از ګټ نشم دوباره کوم. دا کوئی دا کوړه درنه نه وړي دا دا خبرې کوم په مشکل وړي. دا سپکت دی. دا سپکت دی. سیدا کی وړي. دا نه وړي. دا نه دا ډېر بیٹری وزنی بیٹری ده. دا ډېر راولای و. څه کار کوي دا بیٹری بار زموږه ورناس دي. زموږ ته پرځای کی دا تاسو ټیم راځي. اوس په سره راځي. ونه سبا یا. कोई वो रस्सी तो रस्सी ते वो जो लमंड आसान है यार ये बड़ा दा रस्सी वाला. Okay guys, welcome back. I just handled the customer. I am shut down my shutter. Okay. Now we was talk about this calculation. So getting to calculator. Here we have a 212 voltage. You need to multiply. This is the law of when you give to AC voltages to bridge rectifier. So you can need to multiply by 1.41. Okay, this is the result. This is the cause of receiving 298 voltages. Okay, now we need to check. Here is install a UC3843 per PWM, but in this case I think this is not damaged. So first of all we need to keep our multimeter negative probe. Set your multimeter on DC voltages. Okay, here, and keep the multimeter negative probe on the charging MOSFET pin number 3. Okay, and keep the multimeter negative probe positive probe on the pin number 1 gate voltages. Here as you can see we are receiving a 0.967 voltages. Now I am showing with the oscilloscope. Okay, because uh, we cannot show on multimeter. Okay, the law you can check. This is the law you can check with oscilloscope. Okay, so I am connecting the oscilloscope with this gate drive voltages. Okay, first I need to set my oscilloscope for this. Okay, I have a mini oscilloscope and a big oscilloscope too, but I install on my bench a mini oscilloscope. Okay, and I am working on this. And here you need to look to oscilloscope. I am sitting, man, don't worry. But okay, I was sure, but this is for your surety. Okay, as you can see now I am keeping the oscilloscope negative probe on the source and the oscilloscope positive probe on the gate, and let's check the PWM signal. Okay, I am zooming in. Okay, and okay, I am removing my mobile from the stand. Okay, I need to remove my mobile phone from stand. Okay, this is our source pin of charging MOSFETs. Okay, this 3 MOSFETs and the series in the parallel. Okay, so here is our source pin, so we need to keep the oscilloscope negative probe on the source. Okay, and we need to keep the positive probe on the gate. And here as you can see the PWM signal is okay, so this signal is okay. We can use this PWM for the charging. Okay, if when come another device like this and we have an issue in the charging PWM, so I will share you again. Okay, but this device is now ready and I am teaching you about how you can find a faulty charging system. Okay, I am giving you some tips here. Okay, first I need to remove the AC power. Okay, I remove the AC power, and now I am teaching you. Okay, I am zooming in. Okay, to show you a close view. Okay, but here I need to show the multimeter. So first you need to check. I am telling you. Okay, the symbols of faulty charging system, AC charging system. Okay, here is install 100 ohm resistor on the gate. Okay, as you can see here, install 1000. The last zero is multiplier, so this is the zero. So we have 100 ohm resistor. Okay, and here is one diode, and here is one a 10 ohm resistor. This, from these three components, you can find and you can confirm this charging system. Okay, and for this another MOSFET, here we have 100 ohm here, 10 ohm here, and one diode. Okay, on the third we have one. So you need to check. I'm zooming out. Okay, our best teaching. Here are some conformal coating, and I was not moved because first I checked this. Okay, because this is the symbols of faulty charging system. Okay, this is the 100 ohm resistor. Okay, so this is okay, this is the one, and here install a 10 ohm resistor. Okay, on the conformal coating you can read with a little bit hardness. Okay, this is the 10 ohm, and here we have another 100 ohm. As you can see, this is okay, and here is another one 10 ohm. This is okay, and here is another 100. It's okay, and here is another one 10 ohm. So I can believe on this charging system is okay, and I checked with the front of you. Okay, so this is the faulty charging system icon. Okay, if you receive the board and you find the broken or burn or open value resistor, so you need to remove the UC3843. And when the next case come for me, okay, to solve, so I will share with you. But now we have no issue in this charging area. Okay, now that I just get a one sip of green tea. Okay, so now the turn of installing this charging MOSFETs and this IGBT. Okay, so this was our faulty and damaged bridge diode. Okay, as you can see, don't worry about anything. Okay, here is, as you can see, this bright diode was damaged through it in the scrap. Okay, now I am checking the components, so I need to keep on the side this main board and to show you how you can check the faulty IGBTs or MOSFETs. Okay, this is the MOSFETs and IGBTs. Okay, on the left side we have N-channel MOSFETs. Okay, so how you can check? This is the pin number 2 drain. Okay, I need to show the multimeter. Okay, that's okay. Keep the multimeter negative probe on the MOSFET drain pin number 2 and keep the multimeter positive probe on the source pin number 3. As you can see, 505 ohm resistance. Okay, now we need to apply the positive voltage on the gate pin number 1, and after that we need to 0 ohm continuity. Okay, as you can see, the MOSFET is switched. Okay, and now if we apply the negative voltage on the gate, now here we have again a 500 plus ohm continuity. As you can see, this means our N-channel MOSFET, this is okay. Now we need to check another like this. Now the MOSFET condition is on the switch mode, so we need to apply the negative voltage, but the gate is short with the source. Okay, so this MOSFET is damaged. Okay, now the turn off this, but this is already okay, this is the marker line. Okay, so we need to check this with the same method. Keep the negative probe on the drain pin number 2. Okay, now we need to apply the positive voltage on the gate, and now we need to 0 ohm resistance. Okay, that's okay, and this is the multimeter, 0 resistance error. Okay, and now we need, okay, MOSFET is switched. Now we need to apply again a negative on the gate and check it's okay. These two MOSFETs is okay, and this was damaged through. And now how you can check the IGBT? Okay, the methods are different. Wait, I am getting a sip of green tea. Okay, now this is the IGBT. How you can check the IGBT with the multimeter? Set your multimeter on the continuity mode and keep the this is the first method. Okay, keep the multimeter negative probe on the middle pin collector. Okay, here we can call the middle pin drain. Okay, and source, because this is the N-channel MOSFET, and here is the IGBT. So here we can call this pin to collector and this pin to emitter. So you can need to check the multimeter negative probe on the collector pin number 2 and the positive probe on the emitter pin number 3. As you can see, here we have no any resistance. Okay, keep this on the side, I am teaching you for best. And here we need again this is short. And now how you can find a true IGBT? And this is the short. This all IGBT was shorted. Now I am teaching you how you can check a true IGBT in this IGBTs. Okay, this 4 IGBTs was already short. Okay, now I need to throw in the scrap like that. So now I am getting IGBT to teach you. IGBT 4063. And here we have okay, this is the IGBT. So how you can check? Keep the negative probe on the collector and keep the positive probe on the emitter. As you can see here we have a 300. Okay, I'm setting the meter 394 ohm resistance. Now this is the one side. Okay, now you need to keep the negative probe on the emitter pin number 3 and keep the positive probe on the collector pin number 2. In this time we don't have any continuity, and now when we apply the positive voltage on the gate, so now we need here continuity. As you can see 383 ohm resistance, and now if we apply a negative voltage on the gate, after that we have no need to any continuity, as you can see. So this IGBT is okay. Now I need to install the IGBTs and N-channel MOSFETs. I'm getting the IGBTs. Okay, here I have a full out IGBT of ST company. Okay, because here we have not find new IGBTs, so the result has good. Some things I found like this N-channel MOSFET. Okay, now how we can check this IGBTs? Now I am checking this. Okay, because this is the pull out IGBTs of, as you can see, the ST GW60 60 and 65. Okay, and the company installed GW40 and 65. So this is the good from the GW40 and 65. Okay, okay, first we need to check IGBT. I never found a one shot IGBT and this pull out, and now we need to check one by one. Okay, if you checking a lot of IGBT, so you need to check like this. Okay, this resistance is true, another, this resistance is true, another, this resistance is true, another, this resistance is true. Okay, now reverse the multimeter polarity. Okay, no continuity, it's mean okay, no continuity, it's mean okay, no any continuity, it's mean okay, no any continuity, it's mean okay. And now apply the positive voltage on the gate. Okay, and now we have a continuity. Okay, off again, we have no, it's mean this IGBT is okay. And now we have no continuity, apply the positive, we need to have, as you can see, off again, Okay, now we have no. Okay, this is okay. And now we have no need to continuity. Apply the positive. Now we need to have, as you can see, now off again. Okay, this is okay. And now turn off the last. No any continuity. Apply the positive. Now we have again apply the negative. No need. Okay, this for IGBT as okay. So we need to clean this IGBT. Okay, how you can clean this? Get some thinner. Okay, and clean this area. Okay, and when I clean this, I am showing you, and no any complaint I found in this, and I am repairing with the money back guarantee for 10 or 15 days because here are falling a lot of lightning. Okay, so I also telling the customer to check for 10 days in case if you are not satisfied from my repairing, so you can get again your money. Okay, so we need to clean the pins of most IGBTs. Okay, we remove all the extra solder. Okay, and now we need to remove the pin for proper soldering, but here are some rust. I am giving you some more tip in this. I am getting some cleaning paste. Okay, okay, here's take a screenshot of this type paste. Okay, what I am setting, light is come from where, man? The camera. Take a screenshot. Lightning. Okay, now the clear view. Take a screenshot. Okay, for purchasing. No any advertising. Okay, I don't know this company and this company don't know me. Okay, I am just giving you a tip. You can use. I give this to my brother, and he use I think a soldering iron in the box. And I told them don't use the soldering iron in this box, but he used, and this is my best. But my brother is working of electrical devices. Okay, after providing this paste, you need to just check the magic. Okay, the paste is falling down because I keep a piece of this. Okay, now I am showing you the result of the pin cleaning method. Okay, now I am cleaning this IGBT pins. Today I speak more than talk and more speed, but I don't know why. Okay, now check. Wait for better focus. Now you can check the IGBT pin, compare with this. Okay, as you can see, the IGBT pin is ready for soldering. Okay, so I need to clean all like this. Okay, I clean this all. Okay, first I complete one step for the all. As you can see, okay, okay, finally I clean this 4 IGBT pins, and now I need to clean all the pins. Okay, and this front side and this and all IGBT body. Okay, and focus more than on this. Okay, I am cleaning this side with the new. Okay, now check. I have every solution for every problem in inverters. Okay, because this is my working, and every day I am repairing. Okay, and nowadays I was live every day. Okay, now check the status. This is the ST company IGBT. Okay, this is the perfect for this 3 kilowatt inverters. Okay, because this is the GW60 and H65. Finally I clean, so keep this clean once and keep this on this side. Okay, now the turn off this. First I need to remove all the dust and things from this. Finally I already cleaned this. Okay, now I need to clean this too and going to more work. Okay, because in the middle of installing the heatsink, this working is hard. So now I am cleaning the components and the bulk. Okay, and keep this ready for use. Okay, this is the last one. You can First you can check before the cleaning. And now I am cleaning and you need to focus on this. Okay, first I need to clean all the dust at this one swab side. Okay, and for best cleaning I need to this with another side. Finally, and after the repairing I am running load on this inverter around 2500 watts. Okay, don't worry, I have a system to run this on 2500 watts. Okay, just wait, I have a call. Hello, walaikum salam. Hey, come you please. Saan mo ba? Nung piso? Side. Alright. What brothers? I have a customer to give the UPS. Okay. Bola.
हेलो
अरे खायो मैं
बाजार क्या मतलब यूपीएस पे रागला यूपीएस पे रागला मैं यूपीएस दरड़ मतलब इसमें मुश्किल से बस सोलो गिरा करूँगा मंग तो सब मतलब जो नोमान खान का कोई दिला तो चक्कर थी बाजार के हाँ मंग दर्जू जा
Picture.
फ्यूज समझ लगा फ्यूज
कि खो देम देवे के एक्स्ट्रा
के खोल
फ्यूज वही बार बार मत ट्राई मत कोई बार या नूर नुकसान के हाँ खैर सही दरा वाले यार दादी गाउन भी शर्मा दिखवाए थे 500
सही शो
सही रही मेहरबानी जज़ाकल्लाह I get this is approximately 8 USD okay now I down my shutter again okay finally we cleaned all the IGBTs okay now you can check okay so now we need to this type of MOSFET. This is the Toshiba K K38 and 78. Okay, Toshiba K3878 N channel MOSFET. I have this a new and original. Okay, just okay. One is here, and the second. Here is my Toshiba K3878 box, man. Yeah, where? Help me, guys. Where my K30? Oh, pound. Okay, this is the original I found. Okay, Toshiba K3878. Okay, so I am using this with confidence. Okay, but this too I can use in a small inverters, because in the small inverters is just two in the parallel. In the previous live I was told you already, this is I keep, because this is the same serial and this is the same serial. So first I need to bind this together, this two same series. Okay, with this to use next time, because this is the expensive thing. Okay, and this MOSFET is ready for use in 12-volt system, because the serial number is same. Okay, so I am keeping this in the box. Okay, for this in the small inverter. Okay, because I am purchasing this one piece on one USD. Okay, here. So I am now installing this 3, because here we need to install a one serial number MOSFET. Okay, as you can see, this is the one serial number MOSFETs. Okay, because I purchased this all in a single time, so this number is all same. Wait, brothers. This was my promise, because I am repairing this. Otherwise, I am not responsible to repair everything in life, but this was my promise, so I am doing. Okay, now we need to install the heatsink. Before something we need to check. Okay, but we have already this components. Okay, so we don't need to more wait. Okay, so we need to install the heatsink and install the IGBTs and charging MOSFET. So this was the heatsink. Okay, of this inverter. I keep this on safe area, as you can see. Okay, now we need to install the heatsink first. Okay, and here we need to check for conductors things. Okay, and now we need to check this is two diodes. Okay, this is the 8 amps and 1200 volts. Okay, the number is 8120. Okay, I need just to check this. I'm checking. The one is here. Okay. Reverse the polarity, as you can see, and the one is here with the same polarity. Okay, this is okay. Just we need to install the heatsink. Okay, now I am rotating my mobile phone for best direction and need to set this area. Okay, and now okay, this is the direction of the heatsink. Keep here and slide slowly. Okay, here take care for the thermopads. Okay, don't apply the force. Okay, just fix. Okay, now we need to tight some screw on the heatsink. So I am also giving you one tip. Keep all the main board internal screws in another box. Okay, this is the body and the board fitting screws. Okay, and this is the main board screws. As you can see, all screws are very clean. Okay, so here we need to tight first the heatsink with the 3 screws. Keep the finger like that on the heatsink, and first you need to set the hole of heatsink. Okay, and if you have like this screwdriver, so you can easily install. Okay, this screw, and now we need to fix another screw. Okay, and the first one screw, I think this knot goes that way. No man. Okay, this is the pre, as you can see. Okay, and this is not the pre, it's not on true direction. Now this is pre. Okay, but one thing, this is in the company flaw. As you can see, this is all the same screws, as you can see. Okay, but I'm also removing this screw from here. Why? Because I am zooming in to show you a close view. Okay, here we have a screw. Okay, and when I tied this screw, wait, okay, it's free, and now check the gap, a very small gap to connect with this diode proton pins. Okay, so I need, with my true duty, to remove this, because this screw have a bigger washer. Okay, So here we need to don't install this screw. Here we need, I am replacing this with my own screws just for best performance. So I am keeping in this and want to remove this type of screw, but this is long. Okay, so I need to this type in the short length, but if we install the long, it does not matter. Okay, it's better than the short because heatsink is now, as you can see, you check the washer is the smaller from the screw, as you can see. But where I am showing you the difference. As you can see, this have a very big washer. Okay, so here from, okay, I'm going to my tab again because when the customer come, I'm closing my tab because they also ask this, what are you doing online? So okay, now you check at yourself the distance. Here the screw, as you can see, now we have approximately 1.5 mm distance. Okay, with this line, as you can see. Okay, now I am zooming out and teach you more how you can install safely the thermo pad. First we need to install the NTC HDR heat dependent resistor. Okay, and now we need to install a thermo pad. So we need to keep distance the MOSFETs, the diodes, and the heatsink. Okay, a little bit distance for the thermopad. Okay, so you need to separate this. Okay, first I need, but I forget it, so I can now. And this is the thermopad of this inverter. Okay, first we need to confirm. Okay, this is the IGBT's side, this is the N channel. Okay, so now I am installing. First you need to clean. Okay, this is the hair, I don't know, like that. Okay, touch them slowly to remove all the dust. Okay, are clean, but the heatsink is already cleaned. Okay, because I was keep this on the safe and clean area. I was don't keep this in the scrap. Okay, so you need to slide this. Okay, like that. Don't apply the force if not the sliding. Okay, slide to install. Okay, as you can see. Okay, coming. Okay, command. Okay, here are we have to need more separate base diode. Okay, I'm keeping some. I'm using a diffuser to separate a little bit more. Okay, but here is a glue. So okay, now the thermopad is coming. It's okay. Okay, now fix it very perfectly. Okay, as you can see. Okay, I can't more talking, but you need to understand, okay, what I am doing, because don't talking. Okay, now we need to install one screw for holding our thermopad. So we need to install this isolator and tightening thing. Okay, here this is our first one. Fix this. Okay, as you can see, this is fixed, and now keep the screw and your screwdriver, okay, like that. Okay, and now slowly enter the screw and don't apply the force at the screw not coming going and the heatsink. Okay, like that. I am tightening this with the help of fingers from this rod. Okay, this is just show for you. And now I need to tighten this perfectly the force we need. Okay, I install this. Okay, I am keeping the charger to my camera because my battery was low and the device warned me. Okay, now we need to install all these isolators and for tightness the components. Okay, here we need first to keep this. Okay, I am setting the charger wire because the camera is, oh man, I fall down the charger wire just attaching with something. Okay, I attached, and now we need to tighten the screw. Approximately this working is need for 5 minutes. If you are bored from this, you can watch, and after the live stream you need to skip this for 5 minutes approximately, because this is the sensitive and very okay. Here are very cold weather, so I am wet man. I have a call and a customer just tighten this screw because I can't in the middle of tightening this screw. Okay, I tied this and I am receiving the call. Sajida, خامس إذا جت كلها side. Okay guys, you need to wait 2 minutes because the customer has come. Okay, I am locking my all devices. Okay, and the main camera is open. اه ده بس ده الموتور ده دي شارت ده دقيق زمورة موتور ده سوداني زه د امپورټډ چې کوم دي کنه دا زه د کار کوم د دې څوک کوي د دې پول نه پورې لاړ شي دا اپر سوات هسپتال نه لاندې یو هلک ناست وي په زلرۍ هغه د دې ګډ کومو میکس شیزونو مرمت کوي لکه دا هر قسم شیزونه زه صرف دا کم بهرني شي دي که نه بهر نه شي راځي زه د دې را سره سودا دا پر سوات هسپتال نه ماسکو دوکان نه دی هغې په خوا کې دی زما نوم ورته وایي که ستاسو سرپل پهچان وي بیا خو بله منډه ښایي او زما
او دا شرایط لیک کولی
د دې یو زه یم یو دغه هلک دی خو زما سره سودا نه چه واسطه کنه جی راځي چه واسطه لاړې دي الله پاک Okay, welcome back. Sorry for the wait, but we have some customer and they want to give me another device without my field because I am just repairing the hybrid solar inverter, no anything more, because here I am the specialist of this type solar hybrid inverters. Okay, now we need to install. Don't apply force when the screw not going on the heatsink smoothly. Okay, tight the needed force. Okay, are the demanded force. I don't know about this in English. Required force, I think. Yeah, apply the required force. Now the turn of this 3. Okay, I am unlocking my device to view my live stream. Okay, it's okay. Now we need to hold one more screw. I am not just to increase the video time, but this is the duty of me. Okay, lots of people here doing the mistakes. Why? They want to quick repair and earn more than money, and I am just doing my duty and earning the money just I needed, and I want to earn more money but on the legal way. Okay, not on the illegal working or bad working. Okay, if you are objecting me on use full out components, so if here we not found a fresh new component and good quality, so this is better for me I am using the pull out for best performance. Okay, tight this with the required force, and now we have another one for another side. Okay, I'm showing you. And it's a little bit more hard because I am showing in the camera and installing. Okay, now it's okay. Check my screwdriver. This is the rubber, completely rubber hand. Okay, and don't too tight like this. Okay, when you have a quality screwdriver, so you can just like that. Okay, like that. Just see the experience. Okay, so now we need to check the continuity. Okay, but here we have. Okay, now we need to check the continuity. We don't need to have the continuity with this heatsink of this components. Okay, so what we need, I am showing you. The person who watched my one video, it's not about the solar inverter, it's all about the heatsink related components. Okay, so set your multimeter on continuity mode. Okay, this is the heatsink continuity screw, and this is, as you can see and as you can hearing the beep sound. And now we need to check. Here are the 4 diode. I already keep the multimeter probe. Okay, here are 4 diodes. We need to check this. Okay, check with this pin, check with this pin. Okay, check with this pin. No any continuity we found. Okay, with this heatsink. And now we need to check this with this diode middle pin. Okay, and this diode middle pin, we have a conformal coating, so we need to confirm this with this pin. Okay, it's mean this 3 diodes in the parallel. So once we keep the one probe on the one diode middle pin and another on another middle pin, and after that we keep this with this, we have no any continuity. Okay, and this is our need. Okay guys, wait a 30 seconds. I am giving the this to. Okay, nasa why I am down keeping down my shutter, because I am working on the main road, and the free people also coming with me and wasting my time, and I don't want to waste my time with other talks like society, other more and more and more, and lies and much more things. Okay, so now we need to install the N channel MOSFETs. Okay, for the easy installation, you need to cut or you need to bend at here for easy installation. Okay, again you need to fix. Okay, and you can install easily like that. Okay, I put quickly. Okay, and after that you need to straight again the pins. Okay, and where you want to place you can. And now I am installing the screw, this long screw for this N channel MOSFET, charging MOSFETs. Okay, K3878 Toshiba. So okay, don't apply the force, tie it freely first. Okay, apply the required force. That's okay with this finger. And now I am installing the second MOSFET, and I need to order this type of MOSFET, and this is available in our country, and I can receive this in 4 working days. Okay, bend this in another area. Okay, now it's very little bit hard to install. Okay, now that's okay. I install this. Now keep on the targeted area, and now keep the screw and freely install the screw like that. That's okay. Now we need to install a third MOSFET. Okay, here is our third MOSFET, but I need to the angle tweezer to install this. I'm trying. Okay, it's done. Need to push. Okay, now straight the pins and install. And if you know about how you remove safely this thermopad, so you can watch the previous live. I was already added the video link in the description of this video. Okay, how can I remove this safely? Okay, now we tied all the N channel MOSFET, and now we need to solder this. Okay, and straight perfectly. Okay, once I cut the extra pins, first you need to cut the extra pin. Okay, leave the 2 mm or 2.5 mm. Okay, and the extra you need to cut. If you can cut in hold in the tweezer as you can. Okay, or keep in the finger with gloves or without gloves as you can. Okay, and now learn about the soldering. Okay, if you have experience about the soldering, this is better than keep your soldering station or soldering iron on 380 or 400 degree. Okay, and keep the soldering tip on this area and solder this, okay, properly, because we already checked the PWM for this MOSFETs, okay, and these three MOSFETs in the parallel. Okay, we have one another solder. That's okay. That's okay. What are there? Okay. Now I need to clean. Take care about the assembly components, okay, when you are cleaning the soldering plugs from the PCB. Okay, now I am cleaning the second. Okay, now I need to very clean. Okay, this is the good method. Don't apply much more cleaning liquid, okay, with the brush, because when you apply the liquid directly and brush, so here are coming all the dust and rust and flux. So this is the good method to clean the specific area, okay. Don't make more board dirty, okay. Okay, now check the soldering, okay, and remove, okay. No anyone can objection on my work here, because I am doing my work properly, okay, like that, okay. Now we need to install the IGBT, but I need first teach about how you can install the IGBT with 100% confidence. So for this I need, because the people are watching, for this I need a comment. If you want, so I can, but if you don't want, so I am installing the IGBTs directly with my confidence. But I have no any comment, okay, on this live stream. So I am installing directly, okay, because I have no any comment. Okay, I am installing the IGBT, okay, because I am a little bit hunger, and here is the evening, and here is a winter, and the 5 o'clock, okay, 5 p.m, and the sun set down. Now we have a little bit light of the sun, but we cannot now see the sun, Okay, the sun has set down from the top of mountain. Okay, now I need to install and take care about the thermo pad. Okay, this is the angle user, and don't touch the thermo pad. Okay, take care here. Flash message, what man, cancel. Okay, now I need to stand for this action. Set the heat sink hole, okay, like that. It's okay. Now I need to tight the screw on this. Keep like this, okay, and install freely like this. Okay, if you are not believing, this is my whiteness. It's okay. Tight the required, okay, force. Apply the required force. And now I need to put another IGBT. Okay. One tip I am giving you. Set this direction, okay. Set this like this. Okay. I need to nearest this pin, okay, and now freely. Now I have a little bit touching, so I need to more set. That's okay. Now I have the pin bends, so I need to straight this, okay. This is the plane, okay. I need to keep in this. Take care of thermopad, okay. Focus, and start. Okay, now I need to push a little bit, okay. Finally I install, and now my one eye is closed and I am seeing this on one eye is for west region. Okay, now I need to tight this screw. Okay, freely. This is freely. Thank you for all viewers and welcome to N. Apply the required force. Okay. Now I need to install the third IGBT. Okay. I need to focus. Take care about the thermopad. Just keep. It's okay. And now I need to push, but this is need a little bit more force. Okay. Now my one eye is closed and I am seeing this on one eye. That's okay. Like when you are seeing the M, sitting your M. That's okay. Install freely. don't apply the force. Okay, bend your screwdriver on this situation. If I am straightening my screwdriver, so the screw is bending, so you need to bend or tight this on angle. Okay, a little bit angle for freely tightening. Okay, and after that apply the required force. That's okay. Now I have just one IGBT to install. Okay, I install. Need to push. Why they need force? I think the one pin is not set on the demanded length gap. Okay, now I need to set in this area. Okay, and now I am putting again and trying again. Okay, with a little bit force. Okay, now that's set. That's okay. Don't touch the thermopad. Okay, with the fuser. Finally I just got it. Now I need to tighten this last screw, and after that apply the required force again. That's okay. And now we need to install this. This is a little bit hard to install, but don't worry, I am teaching you. This is, as you can see. Okay, so we have an angle fuser. Okay, and we have just a one isolator for this place. Okay, so we need to set this. Okay, I am setting this on my left hand. Now I need to set. Okay, this is seated. And now how you can tighten this screw, because this transformer cannot give you the access, giving the access to tighten this screw. So what in this situation you need to do, keep this screw and the fuser, and here you need to keep. Okay, and after that you need to try on this screwdriver from the angle. Okay, like that I make an angle and a screwdriver. Okay, and I am just rotating. Okay, and smoothly screw tight. But now we have no tight this. We need to tight this with the help of like this flat screwdriver. Okay, put this in the middle and tight this, as you can see, with this finger, and apply the required force. It's okay. Now I am sure this is tight better. And now this is, we have a one isolator screw. Why I am also telling you, because we need the one isolator screw, and we have just a one isolator screw. So now install. Okay, and here you need to make again angle and your screwdriver. Okay, if you attach the screwdriver straight position, you can tight this. I am tightening, as you can see, with the fingers, but now the screw is a little bit tight. Now I want to remove again and need to try again. Now I am trying on this, but don't apply the force. Now the screw is tight, so I am looking what happened here, why the screw is not going in the heatsink. We need to focus why. Our diode is a little bit out from our required place, so we need to set apply with a little bit force, but we can set here easily to solder the one pin, to melt the solder of this one pin. Okay, and need to set. So I am melting. Okay, now not set. Okay, I melt another solder. This was okay. Now I think now the fix. Okay, so we need to try again with this screwdriver. Don't apply the force, okay, for tightening, because the force is not here to apply. Now as you can see, the screwdriver, okay, screw is going to tightening better. Now I am trying with this little flat screwdriver, okay, because they are adjusting here and tight. And now we need to check the continuity with the heatsink of these two diodes. So we have already this diodes pins here. Here we have a 4 pins, and here we have a heatsink screws. So this is attached already with the heatsink, as you can see, and this is the diode pins. So we need to check the continuity with this, and now we need to check this continuity. I am keeping this multimeter, as you can see, the multimeter is attached with the diode pin and no any continuity. Now with this, now we need to confirm the continuity, but don't touch probe, okay, touch the diode pin. So we have no any continuity. Now we need to check this, no continuity. We need to confirm the continuity, as you can see. And now we need to check this. Now we need to check the continuity, as you can see. So our diodes are successfully installed. Now we need to check the IGBT continuity, okay, with the heatsink. So here we have a screw of heatsink, as you can see, and this is the middle pin, center pin of IGBT. No any continuity, that's okay. No any continuity, it's okay. No any continuity, it's okay. No, 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 that's okay. Now we need to solder the IGBT pins, okay. Zooming in, I am keeping the screen on the safe area, and this, okay. This is the IGBT pins. Set your soldering station on 380 or 400 degrees centigrade and solder this. Okay. It's okay. It's okay, man. Good soldering. Okay. Always use good solder wire. Okay. Don't use. Okay. I solder all the IGBT pins, and now I need to clean. Okay, we found. Okay, it's clean, as you can see. Okay, now we need to install the big capacitor, and I am zooming out. I'm going to zoom out, but I wear a glove, so it's little bit hard. Okay, now we need to install this transformer and this capacitor to check the output voltages. Okay, we don't need to install this heatsink because we are not running the load on this inverter, just checking. Okay, so, and we have already DC to DC boost section, and we have a one capacitor. Okay, so the second capacitor with the parallel in this. Okay, so for the nearest result we need to install minimum one DC capacitor. Okay, because we have no any capacitor like this. Okay, I'm installing this one capacitor first, because when you install this and install the transformer, it's hard to install later. Okay, keep your finger like this side, and always I am giving this tip to you. Hold the solder like that. How I can. Okay, give some solder to your soldering tip, and here attach just for holding the component. Okay, any component you can install with this easy method, and after that you need to proper solder another pins of components. I need to boost my soldering station to 400 or 420 for best soldering. As you can see, the solder are melted properly, and now I am soldering another pin. Okay, this was the big soldering. but we can easily solder of this method. Now we need to clean. Okay, we install one capacitor. Okay, it's enough for just the test. Okay, and once the inverter going start. Okay, now how many components we need to install for the output voltages? We need for the cooling fan, because this is the artificial intelligent. If we don't install the fan, they can't output. They can, but they cannot. Okay. So I have my fan just for feedback. I am installing this to give us just feedback. Okay, because we are not running on load on this device on this time, so I install temporary. And okay, now we need to install the transformer, but temporary. Okay, so this was the transformer of this inverter. First we need to clean the transformer pins from extra solders. Okay, this is the best thing. Now I am removing the extra solders from the transformer pin. Oh man, I lock my device. Okay, apply some plugs to the soldering iron tape. Okay, and quickly keep on the pin and remove. Okay, like that. Okay, as you can see, you can throw the extra solder from the soldering tape like that. Okay, and you got the experience of soldering and desoldering. Some people are touch, but when you train, okay, you can remove this with the shock. As you can see. Okay, don't touch anything with the soldering tip and remove the solder with the help of shock. Okay, as you can see. And after that we can remove more with the desoldering wax where I am working, and the camera on the on another area. Okay, remove all the extra solder. Okay, don't apply force, because this is the flexible wires, like the flexible wires. Okay, so now we need to remove this. Okay, and now we need to clean these pins. Okay, we have a little bit solder here finally, and now I am cleaning the transformer pin to install in the board. Okay, we have just more a little bit time to on the inverter, if God will. Okay, remove. Okay, remove, check another area solder you have not. Okay, okay, now we need to install. Okay, the removing video of this transformer already in the channel I have. Okay, if you need to watch how can I remove this transformer perfectly from this board, so the previous video link in the description of this video. Okay, you can watch how can I remove this. Okay, I am cleaning this area finally, and need to install the transformer and need to check. Okay, finally, and now you need to keep the finger on the component, and now like that. Okay, keep your solder like that. Okay, give some solder to your tip, soldering tip. Okay, attach here just temporary to hold the transformer. Okay, here we need to apply some more solder. Okay, the transformer is now attached. Okay, now we need to temporary solder some area just for checking. Okay, follow me now. Now I am soldering just this area for testing. Okay, once we confirm the output is okay, after that we need to solder this properly. Okay, if we need again to remove the transformer, so once we solder this properly, so it's hard for me later to remove. Okay, because the removing method is very hard, so I just solder here temporary. Okay, and I need to solder this pin here temporary. Okay, just for connection, and here I am soldering here just temporary here, and here I already soldered. And now we need to install. As you can see, I attach all the pin just temporary. Okay, but keep a reminder, and one inverter I was forget, and I remove all the board from body again. So and this time we need to write a tag. Okay, and where we can wear the tag when we installing this capacitor. Okay, so here we need to leave a reminder this for this. So oh man, and I solder worst. What? Solder first. Okay, this is our reminder. So now I am putting the control drive card. Okay, This was the damaged control drive card, and this I received, and now I am checking, and the control drive card irons is here, but I need to confirm here. Okay, I am putting the control drive card, just temporary. Okay, once we check, and now I am connecting the LCD, and now you check the inverter. This was the inverter status, man. As you can see, the SPD's condition. What's up? The voltages, man, fall on this inverter. Look at, I received this inverter in this condition. So we have a burnt LCD. So okay, we are replacing this later, but I just remove the LCD strip. Okay, now I am attaching this strip with this LCD. Okay, for showing you, I can read this inverter. This is run or not from the sound and the consumption amps. Okay, but I'm installing this LCD just to show you. Now I am connecting the LCD strip and the control drive card, and here I am keeping the LCD and want to show you. So I need to, okay, this is okay, and here that's okay. Later I am showing you. I am installing the pen strip. Okay, now I am providing the power supply and to check. First I need to increase my voltages or soft apply. Okay, now I need to decrease. First I was decrease, and now I need to increase. This was the big confusion, increase and decrease. Okay, I provide 48 volts, and now I am installing the switch to on. Okay, this resistor is related with the charging section. Okay, when I applying the AC voltages, so we need to install these resistors. Okay, now I am starting. Okay, the inverter is starting. And this time close wear glasses. Okay, googles. Now the inverter 02. It's mean our DC side heatsink is not installed, and the 02 is the temperature sensor is not installed because we have a heatsink here. So I am just installing the HDR because this is the artificial intelligent. Okay, now I install temporary, and now I am turning on again. Okay, I turn on the inverter, and now okay, 04 error, it's okay. The inverter is start. As you can see, on the first time, on the second time, first we forgetted the temperature sensor. Okay, the inverter is start now, and now we need to complete more process. Okay, but here I am hearing some sound, and this is not good. The consumption is true, but I'm hearing some noises, and now I want to check this properly. Why? So I am keeping the screen here, and why the noises are coming from the inverter. I'm turning off, but first I need to check the voltages of this inverter, why they are. I am okay. The voltage is not enough. It's mean our one IGBT is not working properly. So we need to troubleshoot this issue. Okay, I am turning off the inverter, and I need to remove the LCD strip. First I am removing the DC power. Okay, turn on again to discharge the capacitors, and now I am troubleshooting this. Why the inverter is making a noises? Why? So we need to remove this HDR from the heatsink, and we need to isolate the conductive area of this HDR. Okay, this is the board. Okay, so I need to isolate this metal area. Okay, okay, isolate. I isolate this. Now I want to attach with this jumper to don't make me crazy. Don't tie it. Okay, just attach this here. Now I am connecting again the fan. Okay, and now I am checking why the noise is coming from the inverter. So now I am giving the power supply. I am providing the power supply. So here is now our positive. This is the good method. Now I am decreasing the voltage. Okay, for no any spark. Voltage is decreasing. Okay, we found a little bit spark, but this is not. Now I need to install the switch. Here are our switch strip, and now I need to increase again the voltages. First I need to off the switch, and after that I am increasing the voltages smoothly. Okay, and now I am turning on the inverter. Okay, I turn on, and now this is not conductive. Okay, so we can keep this here. Okay, I can keep this here, and after that we have, this is the IGBT source pin, and now this is the gate pin. But very carefully, the inverter is on, and here is okay. This gate drive voltage is okay, and now I'm checking the second. Oh, this is, here we have a 10 volt. Okay, I'm checking, and here we have no any voltages per drive. Okay, that's okay. Here we have, here we have, and here we have, but here we have not. So we need to turn off the inverter. Okay, and after that we need to check the gate drive resistor. Okay, I think the resistor is okay, but I am confirming now. Okay, this is the gate 100 ohm resistor. I am checking. Okay, the resistor is okay, the continuity with the 100 ohm here we need. Okay, and now we can find the issue. First you need, because our autocoupler is okay, because I was checked this first, and now because we are receiving the negative voltages. Okay, and now why we have not a positive voltages. So I am giving you a tip, but this work is a lot of sensitive and taking care. First I need to decrease voltages again to know any spark. Okay, I provide. Now I am turning off the inverter. Okay, the inverter was already off, and now I am increasing the voltages. Okay, and this is the main goal of the repairing this type of inverter. I can keep here my multimeter. Okay, and now I am turning on the inverter, and when we refold the inverter, so this was our autocoupler who providing the positive voltage, but we have not here a positive voltage, so we need to keep multimeter when the inverter is start. Okay, for positive voltages. Now the inverter is start, I am hearing a noises, but here we need to keep the multimeter probe really very carefully. The pin number 2 is the positive pin of the driving. Okay, here we need 700 millivolts for operating, and I am taking, oh man, here we have 1.164 voltages. Okay, and here for operating the positive voltage. Okay, it's very hard work. Okay, to keeping the probes on the autocoupler. Once you make the error, okay, I'm keeping on this very carefully. Wear glasses and this time, okay, because you can mistake. I am not receiving here voltages per driving. Oh man, why? Okay, first I need to clean these pins from conformal coating to read better. Okay. We need to have a voltages all four driving voltages. Okay, so I am turning on again the inverter for best checking. Sometime we have a fault in the main board, and the dealer or distributor send me a control drive card use. Okay, I think, but now I am confirming, and if I receive a faulty card, so I can return, and I'm turning on. Okay, but first I confirm this fault from the control drive card or the main board, from the main board. Okay, now this is the pin number 1. Okay, once the inverter starting the PWM for operating, here are coming voltage, it's true. Here we have a 0.4.1, and here we have 1 volt, and here we have. Okay, now how we can final this autocoupler? Why? When the autocoupler voltage is, but it's hard to read. Okay, now what we can, after the installing the heatsink, first we need to check just the output, and I installed the heatsink, but we can remove now easily because we are solder the transformer temporary. Okay, uh, so now we need to measure this voltages, but if the heatsink is installed and we just do the mistake, so we can lose our inverter. So now I am deciding the law of autocoupler driving. I am keeping this, okay, but the voltage is 21. Okay, now we have on this pin 10 volt, that means this is okay. Now I was make a best multimeter pins for this situation, like this. Okay, so I'm installing I am turning off again the inverter because the inverter are doing the noises. As you can see, this is the tip for you to replace. First you need to choose this type of probes, and after that, okay, I am now installing the angle probes, okay, the angle pins. Now I was isolated this like this, okay, for this situation, okay, and now remove, okay, keep this, okay. Now I need to make this prop custom, okay. Okay, so now we have isolated probe with just a little bit conductive area, okay. Now I am turning on again the inverter, okay. I turn on, and now I am checking the second autocoupler result, okay. First I need to keep the multimeter negative probe on the pin number 5 of autocoupler, okay. And now I am keeping the multimeter positive probe on the pin number 8. The operating voltages is coming here, and now I am checking the output result, okay. We have a 14.6 volts. So first we need to check this autocoupler, how much the driving voltages are coming to this autocoupler. Why they giving me the 14 point some volts? So I need to install again the straight probes, straight pins. Just for this checking, why here are coming voltages, how many voltages here are coming for operating this autocoupler, okay. Here are coming a very high voltages for operating. And now I am checking the third autocoupler. Oh man, do not any mistake here. Menu. Here we have operating voltages. That's a little bit hard to read. Oh man. Okay, I'm setting the inverter a little bit more. Pin number 2 is our positive. This voltage is coming from drive card, okay. Here we have minimum voltage is. So if we first we need to mark our disabled drive. First we need to check this. We need to mark our disabled drive because we was noted on this side. I think our not working IGBT is from this side number 2 IGBT, but now I am again confirming. Okay, so decrease the voltages, install a little bit spark, does not matter, increase again, provide the voltages required. Okay, now I am turning on. I turn on the inverter, and now we need to first confirm what IGBT not working. Okay, first we need, and how you check. Okay, keep the multimeter negative probe on the source. Sorry, this is not the MOSFET. On the emitter, and check the multimeter positive probe on the gate. Okay, again same process, 10 volts. Okay, here we have a minus 0.652 volt. Okay, I am replacing this autocoupler. Okay, I am removing first this autocoupler because I am now I cannot tell about this. Okay, I am just replacing from this side number 2 autocoupler. Okay, first I need to check who autocoupler installed this second. Okay, so I am sitting for this. I need to install one angle probe. Okay, how you can check? I am telling you. Okay, the autocoupler output pins as pin number 6 and 7. Okay, so I am keeping the angle probe on the pin number 6 or 7, and now I need to keep the second probe on the IGBT gate with the 100 ohm resistance. Okay, first I need to set my multimeter on the continuity mode, and after that I need to find this is not connected. First I need to confirm this thing. Okay, here the second number, it's mean the sequence is okay. In some cases the sequence is not okay. I am telling you, for example, this autocoupler was connected to this IGBT, or this autocoupler was connected in some cases with this IGBT. So now I was confirmed this thing. This number 2 autocoupler is connected with the same sequence. As you can see, this is connected with the 100 ohm. Okay, and we was have issue for operating this autocoupler. So now we need to remove this autocoupler, and now how we can remove this, because we install this and this is the hard thing to remove and install here our components, because this designing is very hard. Who designed this? The SMD component they place in the dip area. This is the dip area, okay. So now I am installing another tape, but okay, I am installing an angle tape. Okay. You need to angle tape, or you have not an angle, you can make this an angle, but once you make an angle, so you can use this for angle. Okay, and now I make the angle now. Okay, so first you need to discharge the capacitor. So you need to turn on the switch, the capacitors will discharge automatically. And now I am using this angle soldering tape to remove this autocoupler. Okay, now I am applying some solder. Here I am working with the help of a small piece of mirror. I'm showing you this mirror is the magic for me. I am here using when I have a call. Hello, walaikum salam. जी हाँ د BMS یاره زما سره دومره روپۍ نشته چې زه شیزونه والم که نه. زه د مرمت کار کوم. البته تاسو له ما د جومات دغه نمبر درکړی و، ما وی یاره دې سره رابطه وکړئ، نو تاسو ګورئ چې څه کړي دي. ها نو هلته د هغو دومره چار نه راځي که نه. ها ها یاره زه نشم، زه کمزوری یم. نو یاره دغه بټخیل والا سره به رابطه کوم. یاره موږ له راکوي په 40-45 کې راکوي. نو څه شو ویلی جي صحیح ده، صحیح ده، صحیح دی، صحیح. Welcome back. Okay, we're talking about the mirror like a dentist. Okay, so if you solder this, you need to solder. Okay, you need to keep a small pieces of mirror. Okay, and after that you put the mirror of piece and this area, like you are seeing the autocoupler pins. I am zooming in my camera to show you this little bit tip more, because people are watching me for tips. Okay, this is the mirror, this is the piece of mirror. Oh, it's hard to show. Okay, this is the piece of mirror, and you can get like the dentist. Okay, as you can see, the autocoupler pins set on your position. but we are here as you can see here the pins of autocoupler. Okay, now you are seeing this on with the help of mirror. Okay, when I'm removing the mirror you can see the IGBT. Okay, this is the tip. Okay, now I need to remove this autocoupler to confirm the issue is from the control drive card or the issue is from the autocoupler. Why they can't provide positive power supply to operate the IGBT? So now I am removing. Okay. Okay, I solder all the pins of this side and now I am soldering all the pins of this side, and now I need to melt all the pins at a time to remove the component, to remove the auto coupler. Okay, melt one side, melt another side. I need to add some more solder. Okay, and now I am just removing the second number auto coupler. Okay, finally I remove successfully with no any damaging of pins. Okay, and now we can check perfectly how many voltages is coming from the CPU, okay, or MCU, what you want. Okay, don't fall. Yeah, finally. Okay, this is this is this is our targeted auto coupler. So now first I need to check with the multimeter. Okay, but you can't check with the multimeter 100%, but you can check. First I am checking you. Okay, what was the happen in this side? Why our second IGBT is not working? Because the second IGBT don't receiving the drive voltage, and then what is doing nice is now we need to check this autocoupler with the help of theory. The pin number 7 is positive, the pin number 8 is positive, and the pin number 5 is negative. So you need to keep the positive up on the negative. Okay, on the diode mode. First we need this self continuity. It's okay, 563, and now we need to connect this. Here we have from negative side 575, and now keep the negative on the pin number 8, and here we need to more than high continuity. So with the testing of multimeter is this continuity true, but why we not receiving the voltages? So here we need the LED side continuity. Okay, the pin number 2 and pin number 3 is LED side continuity. First I need to clean this because I saw 1.3 something in multimeter, and around about this is the LED side continuity, but I am not recommended you check the autocoupler and confirm. I have a method for this. Okay, now I am showing you how we can check, but first I am checking the drive voltage without autocoupler. How many voltages is coming from CPU, from this MCU? Okay, now I completely remove the second number IGBT, and now I am checking how many voltages comes for driving this autocoupler. This MCU drive this autocoupler, and this autocoupler driving finally this 4 IGBTs. Okay, so first we need to receive a complete drive voltage for operating this autocoupler. The autocoupler operating pins is pin number 2 and pin number 3. Okay, MCU operating the pin number 2 and pin number 3. Okay, now I am turning on the inverter. First we need to connect the cooling fan for feedback, and now I am turning on. I on the inverter, I turn on, and now I am checking the LED side of autocoupler. Here I need to keep the multimeter. This is not the fault, the error battery low, because my power supply is unregulated. Here, oh man, here I am receiving 0.68. Okay, and the inverter finally got in the fault. Okay, because they have no any voltages from this side, so they can goes in the fault. So now we need to check. There is a one diode of output side, because we have enough voltage for operating this autocoupler. Now there is a one diode. I need to check this. What was the issue, man? I cannot read any continuity. I am attaching the angle pins and the sharp pins. Okay. Now I need to check the continuity for this diode. Here is some conformal coating. This is the big hard working to keep the multimeter with the conformal coating. No any continuity you can read. And I am cleaning just with the help of thinner. Okay, now I am checking this diode. Our diode is okay. This is the short key diode, Scotty diode. Okay, this was true continuity. Now the two things. Sorry, man. Wait, man. What? Hi. No. Santa calma, Santa. Bora, tá bom. Okay, now I am deciding what I need to do. If I found the error in this control drive card, so I never purchase from this control drive card provider. Once I trace the fault in their card, so now I need to install another autocoupler to check this, but first I need to check this autocoupler and confirm this. After this I am installing another. But how we can check this with the confidence? So I create this type of PCB for this and attach two LEDs for operating the negative and the positive output. My tip is going to be matching. Okay, first I need to clean, because here we need to solder this autocoupler, and I am showing you how you can check with 100% confidence your autocoupler is okay or not. So here is our first pin, okay, and this is our LED side and autocoupler. Okay, this bit we need in this time to these two pins. This is our LED positive and this is our LED negative. Okay, and this is our autocoupler power supply positive and negative. You can provide this autocoupler from 12 volts minimum and 30 volts maximum. Okay, and now I am applying the 12 volts. Okay, and you connect with the positive because the pin number 8 is positive. Okay, as you can see this red wire, and you need to one LED provide the positive directly, and you need to this LED green, okay, green or blue color, and you need to have one LED red color or other color, and you need to connect another LED directly with the negative side, okay, and install the 1 kilo ohm resistor to the LED side, okay, any one side you can install, okay, but copy from this. From positive side you can install this green LED, okay, and for here you can install with the output pin 1 kilo ohm. Now I am testing the LED, and we don't need to solder this area because I am providing for this. I just need, I created for this, I think we need to provide this 1.5 volt alkaline battery, okay, 1.5 volts. I'm checking the battery, how many voltage is remaining in this battery. This is the negative, okay, the battery is okay. Now we need a thin 2 wires, okay, okay, I already make for this, okay, and already install a 200 kilo ohm in parallel, so this means this is the 50 ohms, okay, 50 ohms resistance. And now I need to provide a 12 volt power supply for operating. Now I am searching for my 12 volt power supply, but I have already a variable bench power supply from 1 volt to 105 volt DC, so I don't need to searching for another DC power supply, okay. So I am just connecting the negative and positive voltages to check the autocoupler, and after this autocoupler we have a ways. I am don't leaving the live until the 10 p.m. and now here is the 6:24 p.m. okay, because I don't want to keep in privacy anything. I don't want to keep in the privacy because this is the main technique and main part troubleshooting and hard troubleshooting part. Some people are through this board in the scrap for this part, but I am just here for this extremes parts, okay. I am a human, I can mistake and my knowledge is limited, but I was also solved these types of faults, okay. My English is not strong, but I am a little bit expert in these things, and I was have an electronics field just from 4 years, okay. Before this I was an electrical field, and now I am installing the straight pins to my probes. Why I am installing again and again? Because this I was ordered this flexible wires. This is the silicone flexible wires, and I make this probes, okay. This is the Mastec probes, and this is you can view This is best for the fingers. Okay, I have many props, but this is my favorite prop, so I am installing and uninstalling again and again. But I am using this with just my hand, not giving to others my multimeters. Okay, now I am installing the positive to the battery positive, just temporary, as you can see. I am not soldering my probes. Okay, and now I solder this just for best continuity. Okay, not for any. Okay, now I am providing the power supply. This is the positive. First I need to create more conductive area for best holding and microcrocodile clamps, because my crocodile clamps was damaged and I need to replace this. Because in one day so many times I am tightening this and this connectors like previous in live. Okay, so this is the positive. I am connecting. First we need to here from positive, first we need to glow the blue LED. First we need, okay, when you provide the autocoupler power supply, because our LED or green or blue LED is installed positive from directly, and when here is no voltages, so the autocoupler needs to provide the negative power supply on output pin. Okay, this is the autocoupler law of this type autocoupler. This is the TLP352. So here our first law is okay, and now I am providing the manual 1.5 volt with 50 ohm resistor to the LED operating side, as you can see. Yes, as you can see. Now I am providing, first we need to attach properly. Okay, and now I am providing to this. It's mean our autocoupler is 100% okay. Why? When I am providing to pin number 1 positive voltage and pin number 2 positive and pin number 3 negative, the green LED is going to off. Why? Because I provide the operating voltages. Okay, now the green LED is very highly glowing and the red is a little bit slow, so we need to confirm this. We need to attach the multimeter. Okay, now I am attaching the probes. We need to, in this situation, how voltages we provide to this pin, and when we apply the operating voltage, then we need the provided voltages on pin number 6 and 7 with the pin number 5. Pin number 5 is negative. Now I am connecting this probes with this multimeter. Okay, and now I am connecting the negative probe with the direct negative, because we are focusing on positive voltages. Now first we need to check how many voltages this autocoupler providing now. Sorry. Okay, Now here is we provide the positive, and the autocoupler is giving us the negative voltage because the LED side is not have operating voltages. So first we need to measure this voltages. Okay, I provided 14.1 as you can see here directly, 14.15, and the autocoupler is providing a negative voltages properly. And now we need to confirm this. We need to attach the negative directly, and the positive we need to attach with the pin numbers 6 and 7. As you can see, this is attached already in this LED. Now I am providing the operating voltages for the autocoupler LED side. Pin number 2 is positive and pin number 3 is negative. As you can see, they providing, it's mean our autocoupler is okay. So our autocoupler is okay, then what we need to do in the main board? Now I am deciding on this method. You can check the TLP352, the TLP the HCPL, much more types of this autocoupler I am showing you. Here we have 315A, the same configuration with this. Okay, I already told you 3150 and 350, okay, with same configuration, and 352 same configuration, okay, and 3120 same configuration. I am showing you here many types. As you can see, this is the 3120. Okay, this is the 3120 HCPL 3120 at pins. Okay, now it's mean our autocoupler is okay. And here why the voltage is you are looking 0.988 or something, because this is the PWM voltages. Okay, in 1 second they are switching some IGBT switch in 1 second 25,000 times. Okay, because some two IGBTs are operating on 25 kilohertz and some two IGBTs are operating on 50 hertz. Okay, and depending on duty cycle on the output load. Okay, so I can't tell you about the duty cycles, and the voltages is related the duty cycles. Okay, if the duty cycle is 100%, so if you switching in 1 second 500 kilohertz, so you not missing any voltages. And if the duty cycle is decreasing, so you need to seeing the voltages is decreasing. Okay, it's the game of duty cycles. Okay, now I am focusing on the inverter more components, because our autocoupler is okay on the theory, on the practical. Okay, so now I am checking the continuity with the help of other autocouplers. Okay, because this hardware like diodes, transistors, NPN transistors are same of all autocouplers. Okay, so we can trace with the continuity. Okay, so now I am keeping the multimeter negative probe on the pin number 2 and positive on the pin number 3 and check what's going on here. 0.602 continuity. Now I am checking the affected autocoupler. Same. Okay, here same, here same. Then why they cannot provide or PWM output? Why? I'm checking here, but why I'm not receiving the PWM? The one thing I can trace, I can trace from here to here, and I so many times can trace here to confirm, but not in this board. In 5 kilowatt, I also trace. And this types of board. Okay, so this was come for replacing the control drive card. Okay, but the customer not tell me again to repair, so they are keeping for pending. And now we have directly one solution to install another card and check quickly, because I received this card in this condition. Now you decide. I am confused. Okay, I am confirming this because they mark true. It's mean something in this. So I am searching for other card to remove temporary to confirm this. Okay, I have luckily another inverter. Okay, I'm just removing this card and I am responsible for all my action and all the reaction for this action. Okay, so I am keeping this board here. Okay, and now I am deassembling this inverter. This is not my okay, but I am also responsible. If I lost anything, I am responsible and I can purchase for this. Okay, this is my own risk. I am keeping this screw. Okay, now I am searching. I want to say one word, but I have no idea to say. I am translating this. Okay, but leave. I have no translation option in my cell phone. You understand? I'm just in the recording mode. Okay, no any can objecting me because I want to in a simple language. I am not a thief. Okay, because this inverter I have from 6 months. Okay, and this is the condition as you can see, but I need to just check the control drive card is okay or not. So I am providing the power supply. Okay, I am always keeping this number in privacy, but now I am not keeping. Why? No anything in this time in privacy I want. This is very beautiful work. I am also talking. Okay, now I am turning on. Yeah, man. I think the card is okay. The control drive card is okay once they provide the display. Yeah, the control drive card is okay. Now we can check quickly what was the happen we have. Okay, first we need to carefully reassemble this because I am responsible for this action. Okay, I always reassembling on this method and reconnecting. Okay, I am live again. Don't fall down, man. Okay, I am keeping one by one screw and the another box. Okay, as you can see here is damage like this, but the card is okay. As you can see here, this is damage. I was replace these lines and previous live link is in the description. I am keeping this air ventilation core with the top core. Okay, now I need to remove this MPPT solar charge controller, so you need to here one screw. Remove this, keep here, and here we have some two screws. Okay, to remove, and here we have if anyone called to this inverter owner, so I am not objecting because he know me. Okay, now I am keeping this with the other parts. Okay, this is the control drive card screws. I'm keeping in the box. Okay, now we need to remove the strip. Okay, and keep with other parts. Okay, okay, of the card we have some carbon. First we need to clean this with a soft brush. And now I'm just checking. Okay, this with iron. Okay, this mean this is the this inverter with the irons. Okay, I am keeping this on the side, and now I am installing temporary to this inverter. Okay, I installed. I'm just checking for temporary firmware issue because this is my first time to replace the control drive card and have this issue. Now I am turning on the inverter, but first we need to install the autocoupler or any risk. Okay, I'm checking this with the same autocoupler. Okay, if we receive the true voltage and good sound of inverter, so now I need to call to the person who delivered me the control drive card. Now I need to install angle tip. Okay, and after that I need to work like a dentist. So first I need to keep on the PCB. I'm just resizing the pin gap. Okay, okay, that's okay. This 4 pin I solder. Okay, solder this properly. Now I need to keep mirror, but in showing the camera it's not possible. Okay, but I am showing the method. You here place the mirror. Okay, as you can see, now I can see the other side of the autocoupler. Okay, now I am soldering this with this position. Okay, set the mirror. Okay, set the mirror. Now I need to keep something to hold this board for me, and I need to keep not conductor thing. Okay, now I am soldering the pin. Okay, now I can see the other side of autocoupler. First I need to give some solder my soldering tip, and now I need some more solder to give and solder. Okay, I soldered the one pin successfully. I can look in the mirror, but it's going reverse. Just feel you're doing the work in the mirror. If you want to moving the right, so this is going to left. This is reverse. You need to focus to move on reverse direction. Okay, I solder this, but I join the two pins both. I need to remove some solder with the help of desoldering flux, desoldering wick. It's very hard to solder in mirror because you can't see directly with your eyes without using the mirror. Oh man, I give a lot of solder, so now I need to remove again. This inverter is totally the government installed this, okay, and some schools and some other areas. And this type of inverter just coming for me, not for any other, because all the people know about me from last 21 years. Now I need to solder one more pin again because I removed the solder, and now this time I need to more focus. Man, solder. Now I am providing some more extra light with the help of my cell phone flashlight. to supervise this soldering. The one pin in the doubt, so I need to resolve this. Okay. I think the card is okay. Finally, I solder this. Now it's okay. Okay. Now I am providing the power supply. Okay. To the inverter and check what's going on. Okay, I need to decrease the voltage to have no any spark. Okay, now the chance for a little spark. Okay, and now I am decreasing the voltage again. It's okay. And now I need to install the LCD. What the LCD voltages and what in the real time voltages. Okay, I install the LCD. Now I am turning on. Okay, now we need just to confirm the issue from the card or in the main board. Okay. Yes, we have still issue. As you can hear the noises of the board. Now I am checking the AC voltages. $190 and in the screen they show 230. So now we need to what we need to do. Give me some time. I'm deciding to solve this issue. Okay, first I need to remove the mirror, but first I need to discharge the DC capacitor 450 volts with the help of this halogen bulb. Okay, and after that I can use the tweezer in the board. Oh man, I am discharging the high voltage capacitor, but where he is? Okay, here first I need to discharge, as you can saw. Okay, I discharge this, and now I can. Okay, and now what we can do for this, so now I am disconnecting the gate drive voltages, the gate drive resistor. with hot air gun. Okay. First I need to apply some paste because I am removing this with the hot air gun. So here I am providing some plugs. Oh, here is a weather which is very cool. This is jammed, but this is enough for us. Okay. Now I am removing this. Oh, man. Okay, I am installing here. Okay, why I uninstall this capacitor or remove? I am now checking the drive voltage. If the negative voltage come from IGBT or what the happened, now this autocoupler output pin is disconnected from the IGBT gate drive pin. Okay. Yes. This poor diode I was check or not, man. Okay, I'm checking this poor diode. I was need first to check this, but now I am checking again. This poor diode is okay. Now we have still an issue. Okay, decrease the voltages. Little bit spark. Don't worry. Okay. Now I am turning on the motor, but first I need to keep on this position. I turn on the inverter, and now I'm checking the gate drive voltages without connected with the IGBT. So here our emitter and here our gate. So I need to keep. Oh man, what is this? Yes, this is our gate. What is this, man? This is our source, and this is our gate. Negative 0.7, negative 4.7, and already disconnected. Negative 4.7, and here when we connect, the inverter is brought to off. What the issue? I think the battery voltage is not enough. Okay, I am increasing a little bit more, and now I am turning on because the inverter not started. The noise is first we hear the noise is sound. After that we need to check the gate positive voltages. Now here we need to a negative. Now the inverter is start. As you can see now here, positive voltage is here, positive. Here we need to, oh man, off before the resistor, but this is not the true voltages for drive this IGBT, because the pipe and the 1.5 is very long difference. So we have an issue. Still we have an issue. This is not the IGBT issue. Now I am connecting again this resistor. Plus I need to decrease the voltages. Okay, capacitor is discharged, and now I was damaged a little bit this resistor, so I need to replace. Okay, I am getting per 100 ohms resistors. Okay. Okay, first I need to solder the solder mask of resistor. Keep the solder safely, okay? Don't touch with the board other conductive area. Okay, and now I am placing the resistor of 100 ohm. Okay, install. Now I am checking the continuity of this resistor. Okay, this is coming from the Optocoupler. Okay, we have continuity, so now I am checking what's going wrong with me in this inverter. First I need to remove this card, okay, because, and first I need to place again, so I am keeping just with the other components. And now I need to install this card, because we found same issue in the two cards. Okay, it's possible, but now we have not any third control drive card, because now we have not any inverter, and now have no any other extra card, because I just received this with very difficult situation, calling again and again to the person in final who delivered the card, and I was anytime contacting to the growatt, but growatt can't reply to me where I found the growatt card. Okay, here we have one NPN transistor. The code is W1P NPN. Okay. For operating finally this autocoupler, I am just reading of this transistor 565. This is okay. Now I'm checking with other pin 603, and here is one diode. I am removing the conformal coating. And after that I need to install Optocoupler. But what was Optocoupler checking about? Okay, I am using here for some time magnifier plus to check this resistor value, and in case my head is showing in the camera, but it's my need to check this. No any data I found, right? Okay, this is the 240 ohm resistor. Here we have 240 ohm resistor. That's okay. And here we have two diodes for operating this Optocoupler, and some more resistors like 01A coding is first I need to. And here we have some glue on this Optocoupler drive, resistors and other components. So first we need to remove this glue safely. Okay, I remove, but first we need to cut this glue very carefully. Okay, measure the components value. Why our drive voltage is not enough here? If the Optocoupler is okay and the drive voltage is enough, then why we can't receive the drive voltage for IGBT? This is the very difficult one. Now I need to remove with the tip picks some glue. Okay, because I cannot damage any copper line because this is the wood. Okay, and the copper is hard from the wood. Okay, so you can here remove this type of glue with the teeth pick. Okay, as you can see I am removing. Okay, okay, finally I clean this. It's okay. Now I am reading the component value. So the first one we need to copy from here because here I can't read. I am copying this value from here. Here is the first resistor value as 500 ohm. So here I am keeping the multimeter probes on the first. $500, that's okay. And here I am keeping on the second resistor 100 and some ohm, and here I am keeping, here I need, first we need 500 some on the first, it's okay, and here 100, okay, and what here 0.914, and here what the value of the third resistor, I am removing this control card to read this easily. Okay, this is the third one. Here we have a value of the third resistor 0.618, and on the second 0.618, on the third here it's same man, okay. Just I confused for this in the not good continuity. I keep the multimeter not properly on this, and I don't need to be happy. Okay, now we have one another resistor. Okay, here 0.5 something, and it's okay, same value. Same value. Same value. So now I have to read this to complete the circuit diagram from the Optocoupler drive pin to here the ULN2003 I need to read. Okay. First I am installing again this. Okay. Need to increase the voltages. Okay, now I am turning on. Okay, I on the inverter. I am reading finally. Sorry. Once the inverter started noises. Okay, inverter is start noises. It means inverter is start. The PWM voltages is coming now, and here we have 0.818. Okay, it means 800 and some millivolts, and here now why we have here 0.391. This value is not enough for driving the Optocoupler. Okay, so we need here first okay, I am replacing the assembly NPN transistor, and again I need to check this, because if everything is okay, then why we have issue and from this side IGBT number 2. But the main issue we have here, first we need here 800 and some millivolts for driving this autocoupler. Okay, so I am removing the SMD NPN transistor. The value or the number is marking code as W1P. Okay, W1P, and this is the SMD transistor. Okay, now I am checking on, but sometime multimeter show the true continuity, but the transistor internal cannot switching. Okay, now I am checking this open area. No any continuity, and then we have with this true continuity. Now we need to confirm we have no any continuity on this pin, so I am replacing just this SMD component, SMD NPN transistor, and I need to troubleshoot this issue. First, I am now checking this transistor in open area. We have a continuity on this direction. This is okay. Now we need in this. It's okay. It's okay. And this I was removed, but I have no any oh man, this continuity is true. 622, and here it is very small. The whole size is 3 mm and 1.5 mm. Okay, I am replacing this just okay. For any doubts about this SMD transistor, because finally switch the autocoupler, the work of this, so I need to add some more solder. If I using a liquid solder or PPD paste, so they creating a balls, and the balls cleaning are very difficult from here, because this is the dip area. Okay, I solder this. Now I am replacing this assembly transistor. Now I need to check again. Take care about every component. Okay, don't hit or touch other components. Okay, use sharper user. Okay, now I am going to turn it on again after some time, because I provide the heat. First, I need to increase the DC input voltages. Okay. I'm waiting some time because I apply the heat, and you know about when you apply the heat to the transistor or autocoupler or IC or diodes, they change the resistance with the heat. Okay, now I am turning on. It's enough. Okay, I on the inverter. Now I am checking what's going on. Once the inverter start and starting the nicest sound, still we have a bad sound of inverter. And now we need to more focus on this. And now I am reading the schematics from other empty PCB I have. I am keeping this. First, I need about the tracks. I was purchased this type of PCB for tracing the tracks. Now I am searching for where, because I am searching the tracing the lines after long time. Now I am getting the PCB. Man, don't fall. Here I keep this PCB. Man. Oops. I not found, man, because I have a lot of inverters in my shop. I, but I need to press this binary. What is the operating method of this autocoupler in this PCB? Okay, now I am searching on this. I am keeping the device at my direction, and the multimeter we can read on the same direction, you and me. Okay, so first I need to trace one easier side this autocoupler. Sometimes I'm checking this NPN transistor. My live is previous from the live working. Okay, I'm very previous. Okay, now I am seeing on other device. Okay, I'm just checking this NPN transistor, and I forget on this position, so I lost my magnifier glass battery. So now I am providing light from my cell phone and reading the component in magnifier glass. Here we have one NPN, here we have second NPN, and third is NPN. Here we have 4 NPN SMD transistors W1P. Okay, I'm just checking this. Okay, because something this is related, it's okay. It's okay, no any transistor in short condition. Okay, after that I need to read all the schematics of operating this autocoupler. Otherwise, I can't solve this issue. First, I need what what the operating method of this autocoupler from MCU. Okay. First, I need to check with the eyes. Sometime we are doing works deeply with the help of theory, and sometime we have a clearly open or burn resistors. Okay, so first we need to look with our eyes. Here are some resistor and ohm. Okay, and here is a lot of conformal coating. Okay, I'm just looking to the board to or burn or open or blasted resistor or transistor or diode, but I can't found any broken or burned or blasted resistor or transistor or diode. So first, on the easy way, we need to check this 20 ohm resistor, but I think this is not related with this man, because the three autocoupler is ready to drive. Why the one is not ready? This is not related. From here we have the issue in two things: one, drive card; two, and this SMD components are operating the optocouplers. Okay, now I am going in deep like a sea. Okay, this is the optocoupler LED positive. First I need to apply some thinner, okay, to remove the conformal coating with soft brush, okay, because the reading are very hard here. First I need to clean. This is the very deep fault, very deep. Okay, I clean. I'm just tracing, but this autocoupler is always connected with here with the ULN 2003. Now I am just searching here for ULN 2003. First I confirm the ULN 2003 here. Here the stacker level. First I need to remove this carefully. Okay. First I need to find ULN 2003. After that I can trace this easily. Okay. Now I am searching deeply, very deeply, like in the sea or deeping in the sea part, searching some knowledge. And I learn always in this deep part, from this deep parts. Now it's hard for me, it's not easy job. You need to invest your whole life, your whole activities in this. After this, you can troubleshoot. And now I am still searching for more knowledge like this. Now where is our ULN 2003? I have not more cotton swabs. Okay, I found some. I have just this cotton swab. This one finger is disabled, and this is too disabled, as you can see. Okay, but I am still working on micro things. Don't give up. Okay, the life is full from happiness, and now I cannot with the opposite word. What the opposite word of happiness? Lime cone, you come again, man. Why you not? Hey, thick, yes, I am thick. Man, I saw your videos. You just upload two videos of cartoons. But welcome, you are my friend because you are watching my videos. Welcome, friend. Sorry, yesterday I used bad words for you, but now I know you are watching my videos, so thank you, bro. Thank you, man. Thank you, friend. Thank you for your love and sweet comments. The name is Lime Cone. Oh, beautiful name, man, your channel. And I know about your subscribers. You have 500 plus subscribers just on two videos. You are very lucky, and here I am doing a micro works and just found and 6 years just 500 plus subscribers, and you just upload two cartoon video and you got 500 plus subscribers. Lucky man. Good luck. This is not. I give to the person hard cash and I receive a doubtful control drive card. This is our condition. Here I found the ULN2003 finally on the bottom side. Hey, thick man. Yeah, lime corn. Oh man, hurts. It's very difficult to show in the camera, but I am trying. But I saw this is the ULN2003. Okay, I am confirming this with another card. Okay, for showing you. This was the damage card, and here first I confirm this with my eyes, and if I clean this with the cotton swab and thinner, after that we can't read the number. Okay, but this is the ULN2003. Okay, now I can read easily this for SMD micro is for SMD micro diodes, and this 4 ICs is operating this Optocouplers. Okay, I am sure on this because was searched about this, and I was come from the IGBT gate to hear the output from MCU. I was just come here, but and another board 5 kilowatt. Okay, long drive control drive card. And here now I am coming. So first we need to keep our board on the side like this, and after that I need to keep the multimeter. Here we have our 4 lines. Okay, so I need to remove this level. This area is empty. Okay, don't worry about I am using the nib. This area is empty. Okay, yeah, the Chinese language are come. Now I can trace easily ULN2003 outputs, and with the help of this pin configuration I can read this. Okay, now I am searching about the ULN2003. I am removing this first. Okay, okay, I remove. I want to replace this ULN2003. First I need to check, and after that first I am tracing the outputs. Hell, I'm gone. Where are you, man? Okay, I was removed the ULN 2003 from my card. Okay, now this is my card. We have 1, 2, 3, 4 outputs, and this is coming here as, yeah, 1, 2, 3, 4. Okay, I am confirming this. Is this here or here? No, no. Why? This first line is coming here, 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 and okay, attached with this pin. As you can hearing and as you can see. Okay, this pin is coming here, and this is coming here. Okay, now I need to mark this on the time. The one pin is coming here. I mark. Okay, I mark these 2 pins, and now I am tracing the third pin. Third pin, 1, 2. This is the third pin. Not coming here. Not coming here. So where they coming? Okay, I need to trace. These 2 I traced, and now this is the third line to trace. I keeping flukely, so I can't found. So never do the flukes. Okay. I need to trace with the microvision. Man, what the micro leveling to repair this type of issue. This is the third line here coming. Here coming. Oh man. I think here we need to receive at this point or this point. Not so. Two I found. Now I am searching for third line. Oh man, the multimeter is off. This was the issue because I am hearing the beep. Yes, I think the multimeter was off and I am hearing. I am tracing always the continuity with the sound. Okay, so this is our third line and this is our fourth line. Finally I confirmed, so I need to mark this on the time. So finally I mark this 4 pin. On this 4 pin we are receiving from the MCU and the ULN2003 output. Okay, this 4 drive are coming here to this 4 autocoupler to drive the IGBT drive. Now I need to trace this pins. Okay, so first I need to confirm and this card from this side to this side, so we need to this 2 pin and this. Okay, and other this 2 pins on upper side. Okay, so now I am confirming this. This is this is the one side. Okay, 1 2 3 4 5 6 7 8. Okay, the 9 and 10 from this side. Okay, the 9 and 10 from this side, as you can see. 1 2 3 4 5 6 7 8 9 and 10 we have here. 1 2 5 6 7 8 9 and 10 we have here, up and down. Okay, so we have finally we need to mark this. Lime Con, how are you? Okay, 1 2, yes, 1 2 3 4 5 6 7 8 9 and 10. Okay, I mark this. Okay, and now I'm just trying to change the ULN to 003. Okay, and after that we don't need to work on this control card because I give a hard cache. Okay, a hard cache to give the person who deliver me this card, so we don't need to touch other things. Okay, just I am replacing the ULN2003, and this is I am replacing with the zero fresh IC. Okay, as you can see, I am replacing this IC just with the new of Texas instruments. As you can see, this is the product of TI Texas Instruments, as you can see the logo. Okay, and this is the ULN2003. Now I'm just replacing this IC. Okay, I'm keeping my ICs on the time. Okay, now I need to add some PPD paste here, or liquid solder you can call. Okay, I am applying this first on my screwdriver for better applying, and now I am just heating a little bit. Okay, to a little bit for a little bit melting this PPD paste, as you can see now. Okay, because here is very cold weather. If you stay on outdoor, so you jam here. And now I am applying with the soldering tape. Okay, and just check the method. First clean your soldering tape, and after that keep smoothly. Okay, as you can see, the solder is fresh now on every pin, and now you need to clean with the cotton swab extra solder balls or solders. Okay, first you need to clean this. I am not more than working in the control card. Okay, now I am replacing the IC. Okay, fix the IC. Okay, as you can see, finally I placed the IC. Okay, everything is right. Okay, now I'm just trying to check, and before the checking I marked the output of ULN2003 pins. Okay, so I don't want to place this IC again. Okay, so I am throwing in the scrap because it's in the doubt. So now I am just installing the control drive card. Okay, I put, okay, or I put it, and now Leandro R, how are you, man? I am live from. Oh, I have unlimited live. Now I have 12 hours and 35 seconds, and I am live from 5 hours continuously. I just drank a 1 cup of green tea in this live stream. Okay, first I need to decrease the DC voltages for soft start, no any spark. Okay, and another way you don't wait for this, I am showing another time if we need. Okay, I'm just connected, and now I need to increase the DC voltages, required voltages. Okay, now I am just installing the switch and turn on. The inverter is on. I'm just waiting to start the inverter, and the inverter started the noises. Okay, we can read this with the noises, no, with no attaching any output volts to measure. Yeah, it's still not working. So this is not about the ULN2003, because as you can see we replaced the ULN2003, and now I am tracing. But first we need to discharge the 450 volt capacitor, and first I discharge on this method, and now I am discharging with another method. As you can see, the 20 watt and 50 about 25 ohm resistor. Okay, so take care of your finger. Okay, and this is, but this is not good idea, because we have no any hard pin. So I'm discharging with my old method. uh, I need to check first the voltages to confirm, because I don't like the electric shock. Okay, so this is this two capacitor. Okay, we have still a 220 volts. So in my case I am discharging with this method, as you can see, or as you can see. Okay, now I am sure the high voltages capacitor I discharged. Okay, and now first we need, after that we can pocket this little. Why I am adding a one screw at a time if I install the capacitor after the troubleshooting. No man, why you sorry, why you need a lot of force? Yes, no, remove, install again. No, they want more force. In the start I told you leave some extra pins to adjust, and this time Okay, so now I am melting all the fins to fix this bridge diode. Okay, first I need, so I can fix from this side with this method. Okay, first I need to melt this and keep a screwdriver on one pin, and one time I melt all the fins, so I need to push. Okay, don't worry about the prints. Okay, I am not damaging. Okay, I pushed a little bit, as you can see, and now I need to check again this. Okay, and now I need to tight this, but they still want more force. I'm removing this. I need to push this side, so I need to attach something to push and this direction, on this direction. Now I need to melt all the pin at a time, and after that I need to push. Okay, as you can see the screwdriver. Okay, now no, not set. No anyone was trained me in live stream, but unluckily this is my second live to facing with very hard part in live stream. Sometime I solve the issue in 1 hour or 2 hours, and this issue is very hard. Okay, I push extra, so now I need to install the best monster tip for this man, because I'm already tired, but this is not hard working. I am set down on the chair. Okay, I am not loading or unloading. I am just doing this with my own risks and investing the time, but I fall. Oh man. Okay. You can't. Man, what the issue I am facing? Just a little bit work going too hard. A little bit working just going too hard. I think it's ready now. Now I am trying again. F. No, no. Okay, I need to remove completely. So finally I am removing this completely. I need to cut the extra pins because I am completely removing this from the PCB and need to completely desolder. Okay. Just come, man. Where are you? Okay. Finally, now I need to clean the holes and install again. I have the time to 12, 10 in YouTube live giving me a limited time to live. Now I have remain approximately 11 hours. This is enough for one live, man. I am from last approximately 6 hours from live, and now I have 11 more hours. It means you can live 17 hours continuously. This is enough for human. Some people are starting the live on the OBS studio and go to the work. But I am who are the one person to doing this thing in real time. So one thing I forgetted the thermo paste, and now I am first I need to install. Okay, I need to apply on this side. Okay, and now I need to apply and tight and solder, and after this I'm going to my issue or fault from where. Oh man, finally I touch my finger with the thermo paste, but it does not matter. I am not eating with this hands. Okay, remember one screw I fall down from the main board screws. Lime cone, remembering me. Okay, I fall down one screw now, as you can see. Apply the required force. That's okay. And now I need to solder this, and after this I need to troubleshoot the part which I have. Okay, now I need just to clean on the time, because we can park it, because we are a human, not a machine. Okay, so finally I get a screw and keep in the box again, and oh God, help me please. Okay, I'm just using my nasal spray, and the sticker I'll remove. Sorry. Okay, now we are going to our previous part. Okay, we installed the bridge rectifier, and I already marked this pin from this side to 9 and 10. Okay, from this side to 9 and 10 we have a pins of drive to Optocoupler. So first we need, but here we have 1, 2, 3, 4, 5, 6, 7, 8, the 9 and 10, 11 and 12 is going on another side to the Optocoupler. So we need to keep the main board on this side, and we need to pin configuration. First we need to remove the control drive card, and after that we need a male headers. Okay, I have just some male headers in this, but this was the solder. I have a one. Okay, but I am cleaning this. Okay, I remove lime Con and Leonardo. I am gifting you this to, I forget it the name. I forget it the name. Who know about this? I am sure in the video. The name. Apricot. No, it's not the apricot, man. I forget it. Apricot or some. What leaf? This is just path. Lime cone and Lendro R. Lendro R 100. Oh man, yeah. You are keeping name in your language, so other people don't understand about your name. So here is our output from ULN2003. 1, 2, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 and 10 and 11 and 12. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I'm keeping this male header pin in 9, and now I am tracing this. This is the 9, so we need at this continuity some resistance. Here we have no any continuity. Here we have 1.3, and here we have 1.5, 1.8, 1.5, 1.8. So I am reversing the polarity at 39, 1.3, at 39, 1.3, and here at 4 at 39 1.3 at 25 1.3. So we need directly continuity. This pin going to what component? So already we check with the autocoupler pin. So here we have a 500 ohm resistor. I think this pin is going in the 500 ohm resistor, I think. So this is the first we need to check here a 500 ohm resistor. Yes, the first one is okay. So this is the first one, and this is the first one. Second here is not coming. So this is the first one. Here is not coming. Here is not coming. So this pin has to come. Okay, another resistor. Here is not coming. Here is not coming. I check the three resistor. Here is not coming. Here is not coming directly, and here is not coming, and here is not coming. Here is not coming. Here is not coming. Here is not coming. So where they coming? This 4 line I am tracing with the eyes. Okay, I think this pin is coming here. No. Here. No. Not here. Not here. Not here. Not here. Here. Yeah. Finally, I found this pin is coming here with the how much resistance? 494. First I was told you. Okay. Okay. This pin is coming to drive over this first optocoupler, and now I am searching for this. This is its mean, or this one pin continuity is coming here perfectly from the control drive card and ULN2003 to where what the components are working, and this board, this pin is coming directly to the 500 ohm resistor. Here as you can see, this is the 500 ohm resistor, and here we checking with the AZ and I can check without this any transformer. If I can't solve this with the AZ method, so I need to remove this transformer again and this heatsink again, and I can check this to connect this transformer with the help of wire. And one here come the 370 volts. So after here the coming of 370 volts, the MCU start the PWM for driving this IGBT. Okay, this is after that when I can't found with the AZ method. like this. So this pin is coming here, 500 ohm resistor. So here we have here a 500 ohm resistor. Wait for it, I am showing you here. As you can see, this is the 500 ohm resistor, and every pin is coming from ULN2003 to this 500 ohm resistor. Okay, and now I am searching after that this 500 ohm resistor. We are going another side. Okay, so I give the multimeter on the other side of the 500 ohm resistor, and this is connect with another resistor, and the resistor value is 01B. So this is another latest assembly coding. Now I am confirming this. What the value of 01B? This is the new law out of immunity. 01B. Yes, man. This is the new law. This is the 1 kilo ohm resistor. Okay. So first we need to check all the 1 kilo ohm resistor. Okay. 01B. Okay. Now second. Okay. Now the affected Optocoupler drive resistor 1K. That's okay. All the resistor in the same values, the 1K. Okay. The marking code is 01B, and after that, okay, this is our one side is going here to the 01B 1 kilo ohm, and same with another component or not. Yes, after the 500 kilo ohm, this resistor side is going to 1 kilo ohm resistor and the NPN transistor. Okay, so we need to check this. Okay, first we receive this continuity. Okay, this is for the affected, I think. Yes, after that, this is wait, man, what the happened? Okay, here they're coming. After that, this direct pin. No, after the 500 kilo ohm, they are coming. Okay, to the transistor pin and the 1 kilo ohm resistor. Okay, so after that, with the 500 kilo ohm, we need to hear the continuity. That's mean we are receiving with the transistor pin continuity here, and after that, yes, we are receiving here are 0 continuity. Okay, now we need to check. After that, this is the optocoupler negative pin to operating, for operating. So first I need to trace this. Okay, the optocoupler negative pin is connected with the NPN transistor output pin. Now I need to search about this transistor W1P. Lots of components I cannot keep in my mind. Okay, W1P SMD transistor. Okay, W1P SMD transistor. Okay, this is the all data sheet.com, and here I found SMD NPN transistor. Yes, where is the emitter, collector and base. Okay, the first pin is base, the second is the collector, and the third is the emitter. So the autocoupler negative LED side is connected with the SMD transistor emitter pin. Okay, as you can see. So I need to check the affected autocoupler side to check this continuity. Here our continuity is okay. Our negative side of autocoupler is connected with the SMD NPN transistor emitter pin. Okay, and now we need to check the SMD transistor collector pin we are going. Okay, now I am checking. This is the collector pin, and this is the one resistor. Yeah, and the resistor value is 01A. That's mean I think 100 ohm of resistor. Yes, I am true. This is the 100 ohm resistor. First we need to check here 100 ohm resistor or 100 ohm resistor of affected autocoupler drive is okay. Now I need to check where this pin is going. Is this just with the 100 kilo ohm resistor or some another pin? Here is no any continuity directly. Okay, now I need to check this collector connected with the 100 ohm resistor, and now this 100 ohm resistor pin going where. I'm just keeping here to check. No any direct continuity. Yes, I found this is connected with the this is connected with the 500 kilo ohm resistor, direct continuity with here. So I need to check here the 100 ohm resistor to connect here with the 500 ohm resistor. So I have this continuity. Now we need to check from where the positive voltage is coming for autocoupler. So I was have an empty PCB for tracing this line, but I does not found. This is my big laziness. I am keeping my component on the non-safe area. Not found I am there is PCB. The positive pin is connected directly with this diode positive, so I need to check the positive pin here is 2 connected. So now this is now the special thing to fire, and the negative pin is connected directly with the diode. This diode is not for us special because they just on the anode and the cathode connected. Okay, this diode is okay, this diode is okay, and this diode is okay, but disconnected not with the same component. Okay, and this 600. Okay, and this your continuity, my friend, give me continuity. But this diode is the number 1 IGBT. Okay, but I need to check. Okay, because now the fault is very hard, man, very hard fault. As soon as possible I am doing this. If I can't today, I am tomorrow again work on this, because this is my next. Okay, so I was replaced the NPN transistor, and the signal are not coming from the card. What the happened? Oh man. Now what can I do? Yeah man, I have a card. I have a card. Just issue an MPPT supporting. Oh man, I remember, but I invest a lot of time, and this is the same card I received from this provider. Yeah. Now this card I was crossed, okay, because in this card I was issue found in the MPPT charging section. So now I am installing this. We not any component removed, so now we just need to connect. This is our third whiteness. Okay, this is our third whiteness for giving the feedback. The first one, same issue. The second, same issue. Now this is the third, and another one technique. If you don't like sparking, so you can first you need to off the inverter switch. Okay, first you need to off the inverter switch and connect with the 100-watt bulb. Okay, as you can see, the capacitor was smoothly charged. Okay, and no need to increase or decrease voltage again. Now I need to start the inverter. Okay, I start the inverter, and now I'm just waiting to on the inverter. Oh man, this card is not going on in the LED. Why? What happened? What going wrong with me? And we have a LED in this card, but this card is not going on. Where is the card? I receive a party card. very amazing life of, oh man, I touch my head with the headlight lamp. Here is the card of the person. I think I replace it. What's going wrong with me? Oops. No. Card. I have this box in the card. Some cards if I found. This was finished. This I need to check. This is finished. This is finished. I'm checking this card. Is on or not on. Okay. Person on. Okay, the capacitor was charged. Now, yes, this card is on. I think this was the person card, but we need to beep to hear a beep or start in the inverter. But no, this card is not okay. Yes, this card is disabled or finished. Okay, I am just keep this power components. This is already damaged card, and this was the person card. But what's going wrong with this? I don't. But this person is not true. I decided I need to find someone other true person, and I am still confused for the card. So what I can, I have another inverter, burn inverter. First I need to mark some card. This is, we have no any iron. It means this is, I'm marking on this. I'm keeping some tape, a piece of some tape, and I am writing on this on red. I am writing a person name, okay, who sent me a card. Okay, I wrote. And now the one way what can I do with this, man? How we can troubleshoot? is no, no man, you are wrong. You are wrong. What we can do now with this faulty drive, we have just one faulty drive. Here we have 240 ohm resistance. To check again some things. 240, 242. Is this the circumstance? I not found any faulty component, and we are received all the signals, and I replaced the ULN2003. After that, I have one more way to. First, I need to close and okay, I was keep the control drive card already. So I was received this inverter. For what purpose I am opening this? Okay, I received this inverter to purchase components because this inverter PCB is completely burned. Now I am deassembling the front of you. I told to this user you need to do approximately, I am calculating in USD, US dollar, okay. Our currency. I told to this user 175 USD the cost for this repairing, and in these 2 days he purchased a used solar inverter of 5 kilowatt, 48 volts and 50,000, and finally they give me to choose components to purchase. I told him, okay, I am not now free. You leave this inverter here, and I check. I remember now this. Okay, this inverter is just come back from our country. Anyone watching, you can call this person. Okay, because I told you in some live stream, if you are a true person, so you don't need to keep in privacy anything. Okay, some people tell me don't use this app, they access your photos and this is and what is. I said always, if in my gallery I have no any bad photos, if they access to my photos, so I don't care. Okay. This is the condition, and I not work this. I am telling you a whole story of this inverter. This inverter come from now approximately 7 to 8 months ago. Okay. And I told to this person, you need to give me a 170 plus USD to repair your inverter. Okay. After that, they, I don't know where, try to repair. Okay. When I was check this, I think the control drive card was ready, and now I am checking. I told you before opening this inverter, the PCB is burned, as you can see. Okay, the main PCB was burned. This is the line, as you can see. He attached the plastic insulating type. Okay, but this is not the working. Okay, and finally the person keep the capacitors in the body. Okay, and give to this inverter cannot to repair, but this is for special. Okay, this is special for me to repair, and I cannot return inverter of this type, and I said I can't repair this. Now this is, as you can see, the MPPT solar charge controller IR 2011 IC was damaged. Okay, because they try again and again, and finally they damage the PV negative connector. And now I'm checking the control drive card. If the control drive card is ready, so I can purchase for this inverter. Okay, and another parts I am keeping in my shop. Okay, and I always note the user number. Okay, to call. Now this is my duty to write some mark. Okay, so this is this inverter control drive card. Okay, so I am tagging on this. Okay, what's on the top or right? Gadaikas. Yes. Okay, so on the day, okay, this is Chikrai Mulvi Sahib. Okay, Chikrai Mulvi Sahib, if you are watching my video, this is your inverter. Okay, I need here to write this symbol on this drive card. What I need to write? C Chikrai. Okay, and another last M Chikrai Mulvi. Okay, this is the name of the person. So I mark this card Chikrai MV, Chikrai MC, par Chikrai, M par Mulvi. Okay, now I am keeping this on the side. And now I am checking this component and this is my whiteness. If the Chikdai Mulvi said my card was okay, so I can give approve with this live stream. Okay, if you are a true person and not a thief, so your everything has come for your goodness. Okay, what you are doing, this is for your goodness. Okay, but it's need first you have a immunity. Okay, if I lost this card and the duration of repairing, I can purchase. Okay, I can purchase a whole unit for this user. First, I decide in my rules, no any rules before duration of repairing, and also people write in her workshop, if I lost the control drive card and the repairing, so we are not responsible, but I am not from those. I am responsible. Why I am damaging the control drive card? I am not able for this. But okay. So if I damage anything, so I am responsible to purchase new unit. Okay. Now I am turning on the inverter, and first I need to check the control driver. Finally they damage. Not turning on. This card is fully damaged. Now this live is my whiteness. If the person said my control drive card was okay, so I can show to the person who give me this inverter CM. Okay, so I am putting this card and this capacitor because I have no any component now to purchase, because finally a repairing person damaged the control drive card and the MPPT charge controller, and this step I am not removing because this is my whiteness. Okay, so before 7 to 6 months ago, when they come with me, on this time the control drive card I was removed. I am telling about this card. Okay, and this MPPT charge controller, I remember this case. I received this inverter in this condition. Okay, I removed the card and check on another board. The card was okay. Okay, and the MPPT solar charge controller was okay. Just need to purchase another main board. But the person who said, as you can see, no any autocoupler we have here. Okay, and I have a lot of autocouplers, just the issue of control drive card. So this video is my whiteness. As you can see, he apply more much current and damage all components, but I am not responsible for this. Okay, because the person who don't keep anything in good condition. Like that, capacitors are openly I receive. This is very hard repairing, and I'm liking to record my life stories. If one day I am success, these days I can see again. Never underestimate any person because they remember me my poor condition. I am poor, but I am not a thief. Okay. I receive in this condition. I am not responsible, but I have to little bit responsible just to attach with the tap. Okay, as a immunity to not damage this capacitor anymore. Okay, the person keep on this position. Okay, like a potato. So I am just responsible to attach this capacitor with something. So I need to attach this with the strong thing, like this step. Okay, after that I am not responsible. When I told the customer the repairing cost, someone asked about which component you replaced, and I am also giving of the inverter repairing live video. I am also saying this: go to home and lie on the bed and enjoy your live inverter repairing video. This is another beautiful thing for me. Amazing, man. I am happy in my life. Some beautiful circumstance is doing or playing with me, but I am happy. This is gift from the God who want to make you strong more than. No man. No man. A person who tight another types of screw. I am something showing you. I purchased this screws, okay, on my money. When the inverter some screw loss, I am, as you can see, I purchased this. I am repairing on this. I am always using my hand, and I always show you lots of components. The screen was okay, but now I have no need for the screen. Oh, man, he damaged the body too. This is beautiful working. Okay, I am through in the scrap, and I need to add one screw from this. Okay, some screw I am adding. Why I am not adding a lot? If you fall down this box, so your all screws fall down. If I fall down this box, so the chance is limited with these screws, not with this. Okay, this is the lesson for you. Every component I am not opening from the zipper. Okay, with this vision, if I fall down the whole box, I never found again, because you know about the repairing workshop. Here is a lot of dust and much more things. And no man, very bad working people also. No. Okay, here. This is the screw of the inverter. Okay. No. We need to install this screw. Just I waste my time on this inverter. Now I am closing and image all the screws areas. Okay, I'm just adding one more screw. Man, and image everything what I can. I just give some pores just to close. Okay, close and keep on the side. So now I am doubtful. Now I have a two doubtful control drive card, because the both are used and the both is, I cannot speak about more this. The fault is the card, control drive card is faulty, or the main board is faulty. We need to decide this. If I am removing and placing again and again, so what the condition going on of the main board? Because I spend a lot of time to repair this and protect the lines and repair properly everything. And now I am removing the component without, so this is not the good thing. So one thing, yes, I remember. Okay, I need to read the ULN2003 data sheet, and after that when the inverter start the noises a lot of, so I can read from the card. Yes, I remembered, man. Yes, I'm just going on Google. Okay, and here I am already on the alldatasheet.com. I'm just entering ULN 2003. Okay, ULN 2003, and want to troubleshoot 7 Darlington arrays. Yes, this PDF. Yes, I am on another device on searching. Okay, so we have here I think pin numbers. First we need to know about our using pins to drive the 4 autocouplers. Okay, and now I can confirm this issue from the card or from the main board. Yeah, I can. Yes, I can. So we have these 4 pins. Okay, yeah, man. Okay, this is from outside. Yes, man. 1 pin number. Now pin number configuration 1, like that. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 7, 8. How our pin using? Okay, this pin we have to need continuity. Why I am keeping some on something? We have one this pin number 9, 10, 11, 12, 13. Pin number 13. Pin number 14. Okay, now I am just checking one by one. Now no continuity. Pin number 9, 10, 11, 12, 13. Okay, 13, and this is 14, 13, 14. Okay, and now 13, 14, and 9, 10, 11, 12. Okay, and I think 11. I think the 11 to 14 we need. No. So what? Yes, to 15. Okay, 15, 14, 13. This is 15. What, man? 9, 10, 11, 12, 13, 14, 15. Yeah, 15 number pin. And now we have 14. Okay, after that 13, after that 12. Okay, 12, 13, 14, 15. Yeah, pin 1, 2, 3, 12, 13, 14, 15 is our output pin. Okay, this is all the same, just we have pin number 9 for the VCC and pin number 8 for the G and D. Now we need to confirm the affected autocoupler pin in this IC. So now how we can this? First we need to know about the pin. The pin is coming here. Okay, so first I told you our directly male header is going in the circuit to this type of resistor with 500. Yeah, first time I found. So this is our not affected pin. After that we need to keep on this and check. Okay, this is not our affected pin. After that we need to here a continuity in the card, in the control drive card. Yes, I found, I think here in this port I marked this is our affected autocoupler drive resistor. So I am keeping this multimeter probe until I mark the pin with the green color marker. Okay, yes, I marked. Now I need to draw some bigger red line to completely sign off this pin. Okay, now our G and D pin, ground pin is pin number 8, and now we need to 16, 15, 14, 13, yeah, 12, 11, 10. Okay, pin number 8 and pin number 9. Okay, this is the power pin, and we have a 7 outputs, okay, to use on the in this IC. So now I mark our special pin. So I am removing the card. This pin going to our affected autocoupler, okay, are our target autocoupler. So what we need to do? We need to first confirm this pin and this pin. Okay, this pin, this is the pin who, okay, this is the pin number 14. Pin number 14 is going to our affected. Okay, so now this is directly connected with this pin, so I can solder here or here the 14. Yeah, 14. I can solder this, but here is not a good thing. I am soldering here a little bit smooth wire, and I have smooth wire to solder with this. Okay, I'm connecting some smooth wire. I already connected with a little bit S circuit. As you can see, this was my project circuit. Okay, and now I need to connect this with the IC. Okay, so the pin number 8 is, look at man, look at it. What is this? No, this is normal. Okay, now I'm connecting. This is the green color word, but ignore. Okay, the color are not working here, not the multiple colors. Here is just in a one color. Okay, colors depending on the experiences. Now I am not installing in the building or true coloring, okay, or symbol. I'm just doing of internal work. So here is coming positive. Okay, don't objecting on this green color, and this is our GND pin number 8. I can, okay, I have a powerful IC to hold this wire. Okay, I'm not soldering this with the microcontroller, and I can this with the microcontroller because I have a soldering experience. Okay, I'm not doing arrogance, but I'm just telling. Sorry. Okay, now this is our GND, and this is our pin number 14 output for this affected optocoupler. So I am putting this in the inverter, and I am responsible for my this action. If I lost this card, I am responsible. Okay, I am responsible for all my action and all the reaction for this action. Yes, now I need to apply the voltages, and first I need to keep this safe. Sorry, and I need to copy another true autocoupler drive signal, so I need to get one another wire, okay, to first measure the IC output voltages of true autocoupler drive voltages. And now I'm connecting. Okay, now I am connecting this wire to another pin, okay, for measure the signal of PWM or voltages, everything you can call, okay. So I solder another pin to first I need to copy, okay, copy the voltages of the true autocoupler operating system, okay. And after that, now I am doing something special with this wire to keep safe. So here, here, yes, yes, man, and this is the GND, and this is our copy line, and this is our third. Now I need to keep this secure. Don't touch with other conductive area. So I need to cut this step, and now I need to keep this. Yes, baby. Okay, and now do something with the confidence. Okay, I protect all the wires. Okay, just here we have our signal. Okay, now we need to solder this area part good for good continuity. We need to solder this area for good continuity. Okay, here I need to solder this for good continuity, and I'm adding some more solder here for good continuity. Yes, I solder this, and now I'm just giving the power supply to the inverter. Okay, with the 100-watt halogen bulb to smooth charge the capacitors. Okay, but the inverter is on already. Okay, okay, I on the inverter. Inverter was not on already. Okay, and now we need to check the voltage is coming from ULN2003. Yes, we have still a bad sound, okay, of operating system. So this is our GND pin, okay, and our white pin just for copying. 2.4 at 1 volt is coming, and here is coming 3.529. Now I need to check this with the oscilloscope. How is the frequency of this voltages and duty cycle of this voltages? Okay. Now I'm just checking. After the checking, I am showing you. Okay. I hope this is the 50 hertz frequency, and this is the 25,000 frequency. The red wire is our affected autocoupler drive, okay, and the white wire just or copying, okay. So here we are receiving the drive voltages from ULN2003. This is the white, just for example, 2.473, and this is the red wire as our affected 3.5 3.520. So now we have here two wires of high frequency and two pins for low frequency. So now we need to attach one more wire to confirm these voltages. Our 100% confirmation, we need to attach four wires. Sorry. Okay, but now I have a marks area of these two pins. Okay, but I am just keeping the multimeter with my own race. Okay, here we have with the white wire 2.469, another side 3.513. So here is our complete game. I'm just keeping this with my own face. As you can see, 1.67 and another I have for this dangerous working I have. So I need to install. Okay. Sorry. We need to install here negative. With the negative, here already we have this two, but we need to read this two. Don't touch, man. Okay, 1.67 and here 1 2.5 2.5. Okay, 2.5 and 1.6 1.6, and the red is all affected. And why the red voltage is high? Because now we have the red voltages 3.5 volt. Why? Because this red wire is connect with this autocoupler, and this autocoupler not operating properly, so we have more than voltage with comparing white or more pins. Okay, once or this affected autocoupler operating, this voltage is going to same. So now how we can check our fault from? So I am keeping this. Okay, and this is the negative. Now I am keeping on the first autocoupler positive pin. So here we receiving 3.9 volt, and I am now keeping on the second affected autocoupler. Oh man, our positive voltages is coming properly from IC, okay, and from card properly. As you can see, I keep the multimeter positive prop on the affected autocoupler, okay, and negative with the use the ULN2003 ground. Okay, now I am keeping the positive probe on the third autocoupler. Here we have 4 volt. Okay, this is the low and high frequency difference. This two autocoupler is for high frequency. Okay, and this two for low frequency, because we have here some little voltages. Okay, and now we confirm our positive voltages as properly coming from control drive card. We just have issue in our negative voltages to operate the autocoupler. So now we need to connect this positive wire with the, we already confirmed this thing. This is our GND of ULN2003. Okay, and every autocoupler positive voltage I check and I receive. So we need to receive a negative voltage for operating the coupler. So now I am attaching the positive wire with the ULN2003. So the pin number 9 is positive. Okay, common freewheeling diodes. Oh, okay. We have issue in negative voltage. Our positive is coming. We need to focus. Oh man, sorry. I touch my head with the mobile. Okay, now I need to check. I am turning off the inverter. Okay. I'm turning off. And now get some time. Okay, it's approximately 10 or 15 seconds. Sorry. Okay, so I am turning on again the inverter. Okay, or soft start, no any spark attach for some second, and then apply. And now I am turning on the inverter. My man, on. Hello, wake up. Wake up, man. What's going on? Okay, first we need to discharge the capacitor. What's going wrong? Okay, this is the reverse polarity protection. We need to check here voltage. Here we have some voltages too. I want to quickly discharge, but no any continuity I found. Okay, now I am checking 15. Okay, now what the issue with the smooth start? Okay, spark. I think I lost a cord. In what condition? I am checking. Yes, we know last card. Okay, we have just issued an our switch. Okay, once the inverter start, I am reading some more points and sharing with you. No, I need to jump for this. Why? What's wrong with you, man? In this serious time, you need to disabling in this time. Okay, I'm just making a jumper per switch. Okay, I'm using this is my own strip, and I'm using this as a like a switch. Sorry again to touch the mobile with the head. Nearly I am purchasing high quality zoom cameras and audio and videos setup. Okay, now I am turning on the inverter, but first I need to isolate this. Okay, I am isolating with a little bit piece of tape. Okay, isolating tape. Now I'm turning on, inverter is on. Once the inverter is started, I am reading and sharing with you from where the issue we have. Okay, we have still bad sound. Now our positive voltages is coming from ULN2003. So, oh, the man is going in the fault. So we need to connect the LCD or showing the MCO fault. What the fault they show? Okay, I attach the screen and now I'm turning on. Remove the strip and soft start. Yeah, attach and now turn on the inverter first. Yeah, inverter is start as you can see. And now when I touch the multimeter positive probe with the Optocoupler positive side of LED, the inverter is going to fault. And now here we have no any voltages. After some time is coming, the voltages are driving the Optocoupler. Okay, we have just 0.054. No man. And why not inverter start, man? We have, oh man, yes man. I am cutting this my wire because we have already lots of doubts, and here we don't have any doubt. So I am soldering proper this bar now, and after the repairing this inverter, I need to install to the switch another switch. This switch was are using from approximately 1.5 years, and the circumstat, this was damaged in this inverter. My goodness. On the inverter. Inverter is on properly now. To jumper. Wow. This is the very difficult issue and my repairing experience. Okay, here we have no any voltage for operating. Now I am keeping another negative. First I need to tighten my pins of multimeter. Okay, okay, and now I am keeping the positive probe on the affected. Okay, and I need to keep the negative probe with another Optocoupler, but here we have no any voltages. What's the mean? Yeah, we confirm our positive voltage is coming here, but the issue from the negative voltage for operating the Optocoupler. Okay, as you can see, the first Optocoupler is perfectly working, and here is what here is coming at 100 millivolts, and here is the voltage ratio is 0.375. It means our negative voltage is not coming here. Finally I found. Now we need to focus on the negative voltage of operating the Optocoupler LED side. First I need to off the inverter. Okay, so or this case is clear, so I need to remove this wire and this tab because the positive voltages are coming from the control drive card, and I am still live from how many hours? 6 hours and 49 minutes and some seconds. And now the time is over, but now I don't want to live in this situation. I need some more work and I have some more energy, okay? Because I worked continuously 12 hours. Okay, and once in a time, once I was a young, okay, and morning we are coming in our workshop and 2008 to 2013 and going from here 11 p.m. That's mean we was working 15 hours continuously like robots, and now I work 12 from 12 hours, but I have some more energy to work, and I have all the night to sleep and enjoy the sleeping. And this is my own work. I'm not here on the job. This is my own business. This is my own property. Okay, and this property on the main road. This is just my hobby from childhood, and this is just my duty. God provide me. I'm just doing my work and eating and sleeping, and got everything giving me just okay. And I'm just doing this type of works, difficult works, difficult, okay, easy works, can everything. If you want to some special, so you need to do some special thing in your life, okay. We have here continuity with another autocoupler 484 volt ohm, and here we have a same continuity with another autocoupler. So what the happen? First we need to check from where the negative voltage is coming. I have another board, the match board. This inverter I have from last 3 years, okay, but the customer not paying the cost for repairing to purchase the cord. This is my starting days, okay, and now I can repair. Okay, this was badly damaged, okay. Now I am looking here to read, but I have a lot of components here and it's hard to find, so I need to quickly remove all the heatsink and transformer quickly. If I want to troubleshoot this issue, so I need to remove. First I told you solder this temporary, okay, and now I am removing all the solders. First I am desoldering this with the desoldering pump, okay, and after that you just watch. This is the amazing issue to solve. Yeah, remove. Okay, a little bit with the desoldering wick, because I have a little bit desoldering wick, just approximately 9-inch. And now the market is closed to purchase the desoldering wick, and I forgot it to purchase on the time. Sorry, I touched the mobile with my head. Okay, now I need to provide some soldering plugs to the desoldering wick like that. Okay, to remove the solder. It's a very fake soldering. Okay, but you can remove this with this. Okay, and once you solder this properly, you can't remove it this or a lot of desoldering wick. Okay, now you can ask. Now you are asking in your mind how you can remove it first time, so you can watch the previous live of this inverter, the description in the link of this video. I am talking with you people. I found in the last, I find you, some people I found you, some people I found in the last. I need to first provide the heat to melt the solder. Okay, okay, this side is clean. Now the turn of this side. Okay, first you need to melt, after that move. Okay, this pin is free, this pin is free. Now the turn of this pin. If I can't today, okay, or tonight, so I am tomorrow live. I will tomorrow live again if God will, and if I live, okay, mean life. If God give me life for tomorrow, okay, so this is my what call wish, no, dreams, no, what's mean, what's the name, I forgot it, all the name in English. I am remembering what my all focus in this component. So in my family sometime I forget it the name of person, and I was hanged sometime to call the person. I forgot it what the name of this person, man. Why? Because my full focus on the technology, not anyone forcing me. Okay, I'm just doing work with my happiness. I give this shop on the rent so I can easily live. Okay, but I am here doing to something special, not just for earning money, man. The money is not just in the life. Okay, some other things important than money. Okay, I will lunch, okay, today, and I am believing on the God who providing the foods, the clothes, the drinks, everything. Not I am responsible to provide foods, drinks, clothes, medicines, okay, all from the God. Now I need to remove this solder, but I can't remove. I melt and the transformer need to fall down. Okay, so my soldering station temperature is going to very hot and damage the desoldering wick and soldering plugs. Now I am trying to remove this solder. I am boosting again my soldering station. Okay. Now I am cleaning this pin completely. But this is my mission. Okay, I am not giving to the customer in this condition. I need to repair this. Oh man, I separate some wires. Okay, but don't worry. They know me. These pins and solders and other things know me. This is the man who are kidding with me from some years, and they don't reactions. And if their reaction, I don't care. I can solve. Okay. Now I need to just remove this little bit solder. My father was first person who start here the electricity works, like voltage stabilizer in 1990, and we have still a trademark of registration and license and everything. Okay, this is this business and this job and this duty first doing was my father, but now I am, and my two elder brothers repairing but electrical devices, and this is the advanced electronics and advanced technology. Now I have this one pin to melt, okay, and to pull down the transformer. Now I am again soldering this pin. Why? I need to melt the bottom solder because I need to remove the transformer. This side is already okay. Okay, as you can see, the transformer is easily removed. No any print out, don't worry. Okay, I am melting this for showing you. This is not the print, no any print out. Okay, just this is all the solder. Wait, I think I damaged a little bit of print here. Yes, yes, I damaged a little bit print. I applied little bit force. This was my mistake. God forgive me. Okay, but here we have a lot of soldering area, some approximately in this area I was damaged approximately 2 to 3 mm. Okay, but it does not matter, like in this big area. So in the live stream, this was my first mistake, to remove a little bit front PCB front, like this. Okay, sorry. What the time? 10:08 p.m. I'm calling to to get permission from elder brothers, because they want to class me when I goes to home. So I'm calling to my elder brother. Okay, and he said yes. So I am still working here. I'm going because I am every day I am saying this. I am just live until the 10:00 p.m. Okay, and now the time is 10:09 p.m. here, and all the market are closed. You know, Barry? Okay, finally I get the permission. Okay, now I am happy because I get a permission. Yeah, man. So I need to remove this capacitor because I am removing the heatsink from the main board to follow the negative line. Okay. Now one thing is that, okay, and why I cannot my monster tape to remove this? Yeah, maybe yes. Install my monster tape. Okay, and a little bit wait to need approximately 20 to 30 seconds. It's going on. Yeah, it's working. Just need a little bit wait more to hit up. Okay, now apply some solder, okay, at a time, and remove easily without any damaging of friend. Okay, smoothly remove, don't apply the force. Okay, finally I smoothly remove, no any print, all the solders. Okay, as you can see, and now I install this solder first, but we have already issue in the board, so I need to remove this quickly. Okay, if you want to how to remove, you can watch the previous live in the description in the link. Okay, I need to remove one more screw from this side. Okay, and now I am removing this all screws quickly. Okay, but not a match. Okay, if you want to how to quickly remove the screw from my screwdriver, so you can, one method is that, and another, I do not touching anything. Okay, and set my M. Yeah, okay, like that. Yeah, I don't touch the box. Okay, like, yeah, but if I touch, I save the time. Okay, and I need some time if I can in this second live stream. This is good for all. Okay, because this is not the good thing you repair one inverter and 3 live streams. Okay, first I need to repair one inverter and 1 live stream. Okay, and the 1 live stream limit is, my limit is 18 hours continuously. So after that I need to repair one inverter and 1 live stream. After that I can't need to again and again. If you want to how to remove, you can watch link in the description. Okay, remove and keep, 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 remove and keep. Now I need to open the screw of heatsink. Yeah, okay, keep here. Here we cannot use this. Okay, okay. Now if you are saying this, how you can remove safely this thermopad, you need to attach here the screwdriver. Okay, and smoothly. Okay, I am removing the strip from the board. Okay, we get again in this shape. I need to keep this safe and need to remove this HDR. Okay, because this is the artificial intelligence. So if I not install this HDR, they're going to the fault 02. Okay, I need to keep here, and now I need to isolate this metal body. Okay, for protection. Okay, now this is isolated. Sorry, here are very cold weather. Now we need to focus. I ask first, but I ask from wrong person. I ask if you want to how we can confirm complete drive voltages on his time. No anyone comment to check or not. So I install directly the IGBTs and heatsink. After that we facing this issue. Okay, so now I need to completely clean this autocoupler. Okay, but Now I need to just remove the autocoupler and trace the negative point. Why our negative point is not, our negative voltage is not coming to this autocoupler for driving, okay, for this drive side, not for operating voltages, okay. These 2 points is the one positive line is coming from the control drive card with the help of UL2003 ULN2003. Okay, now I am removing with my favorite user the SD10. Okay, melt and soft remove. Okay, now I am just removing the solder, the extra solder to remove. Okay, okay, now from this side I have just a little bit time, limited time from home. Okay, not for all the night, and if I get the permission for all the night, I was so happy, but I don't get to spend here day and night. Okay, here I am cleaning and just need to follow the negative voltages. Why are not coming here or drive to this autocoupler. This is the transformer. Okay, now I need to check very cleanly. I waste my time approximately 2 to 3 hours, but this is the repairing life. Okay, don't blame yourself. Okay, this is the repairing life, and this is the 50 hertz life. The 50 hertz. A child who was born in 19. Okay, I need to focus on negative, so I need to near the board with my eyes, or my eyes I need to keep near with the board, or use the magnifier glass to find. Okay, but here I have a little bit light. Now I am getting to find, but this is not the good thing if you are looking in the camera. My head, I am just finding the negative where coming from where coming the negative. Okay, I find some little bit, I think, on this side. Okay, my multimeter is off, auto. Okay, now here is the negative, and this is how much the resistance, 240 ohm. 240 ohm, the resistor is okay. 240 ohm, like this. And now I need to follow more. Okay, on the diode be passed. Okay, and after that the 240 ohm, this voltage is coming is from this diode. Man, the diode is okay already. Okay, so man, what the issue to find? Okay, I need to clean this area little bit more. Okay, and there's we need some natural help. Okay, because we are humans. And now this negative is coming here. No. Oh man. Here, 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 here. Oh. The positive is coming directly from the ULN2003 and the negative is coming from this NPN emitter collector. I was searched for this but I forget it again. So I am here again for this NPN transistor. Okay. Collector. Yes, the negative are coming from the this NPN transistor emitter. So where is the base? Yes, the first pin is the base of this NPN transistor. So this is connected with this 100 ohm resistor. 100 ohm. This is the third resistor. Here, how much ohm we have? 600 and why? 620 ohm, and here 680 ohm. Why? Man, oh, continuity is change if I reverse the polarity. Yes, yes. So, what was the resistor? What is the resistor self value? Okay, the resistor value is 1 kilo ohm. Okay, it's okay. Here is our resistor. So this is connected with the base. Okay, with the base. And now this resistor, this pin, we are going. Okay, this is going and 01A 100 ohm of resistance. Okay, after that, where is coming? Where is coming? Oh, 100 ohm is going to the collector, and another pin is going to 1 kilo ohm, and then here we have a 500 ohm. Okay, our main logic is in here. We have a lot of big issue here on the negative. So the negative voltage is from we are controlling here. I am keeping a multimeter probe. This is the emitter, and this is the connected with the L7805 with how much resistance. This is connected with the 242 ohms, and this the same resistance, and this the same resistance. This is connected from the main L7805. Okay, now I need to find direct the continuity with this L7805 negative. So I not found here the direct continuity with the L7805. Here is the 666 ohm this resistor, and here is the same, here is the same, here is the same. So the second still 666. This two resistor is both resistance, same resistance, this three. Okay, so we need to same with this. Yes, same resistance. And after that, another side we can check 400, 675 at, okay, 400, yes, 675 at 100, that's true, and this 400, 676, okay, at this resistance is okay. Okay, if we connect this without negative voltage regulator, then check this negative pin is connected at how much resistance. If we reverse the polarity, we cannot any continuity. We cannot any continuity with this. After this, what we need? The transistor. I'm checking just the transistor emitters. No, this is not connected in the parallel connection. Okay, the emitters are not connected. This is connected in 1.1. Okay, this is connected with the 1.1 continuity, and this same resistance. So we need to read about. I'm just removing the assembly transistor. Okay, and I need to learn from this board because I was have my own this type of board. Okay, this is the same technology, just one extra autocoupler. Other works are same with this. First I need to complete control on this drive. After that I need to work on this. Okay, so this is not a little game. In this live stream I can't complete this. In the next live stream, and this I am not removing this board from this bench. First I need to learn about more. Okay, and after that I can work with the theory and the practical together. So if God will, we can solve this problem or troubleshoot this faulty area. Until take care, and I am going to home. Thank you for all viewers and all sweet comments and bad comments. Take care. See you in next live. Okay. Bye.